You are lying still now. The day has already drifted away behind you, and the room around you is quiet and dark. There is nothing you need to do, nothing you need to remember, nothing you need to follow closely. You can let your thoughts settle like dust in a still room, slowly, gently, without any effort at all. If you like, you can picture yourself outside on a clear night, lying on your back in soft grass, looking up. The ground beneath you is steady and solid, holding you easily. The air is cool and still against your skin, and above you, stretching from one edge of your sight to the other, is the night sky. It looks like a great dark ceiling dotted with tiny points of light. Some of them are steady and bright. Others are so faint you can only see them if you let your eyes rest on one spot for a long, slow moment. And between the stars, there is a deep, quiet darkness that seems to go on forever. But here is something gentle to hold in your mind, something you do not need to work at or even fully understand. That ceiling you are picturing, that dark expanse above you, is not really a distance at all. It is not something far away, something separate from you. It is something you are inside of, right now, at this very moment. You are not looking at a distant object in the sky. You are sitting inside it, resting in it, breathing quietly within it. The thing you are inside of is a galaxy, and that galaxy has a name. It is called the Milky Way. You have probably heard that name before, maybe in a science class long ago, or in a documentary, or just in passing. It is a soft, old name, a name that comes from the way it looks to the naked eye on a very dark night, a pale band of light stretching across the sky like a faint trail of spilled milk. Ancient people looked up and saw that band and gave it names like that, quiet names, names that tried to capture something of its gentle, misty appearance. And that is still what we call it today, the Milky Way, our home galaxy. And you are inside it right now. As you lie there, as your breathing slows and your body settles into the mattress, you are tucked inside this enormous, quiet structure, held within it as gently as a single drop of water is held within a vast, calm ocean. You are not looking up at the Milky Way from outside. You are looking out from within it. Every star you have ever seen in the night sky, every single one, is part of this same galaxy. They are all around you, above you, below you, in every direction, even though the Earth itself blocks much of the view. You are swimming in a sea of stars, a sea so vast and so calm that you do not feel its motion, you do not hear its sound, you do not notice its presence at all during the busy hours of the day. But it is there, it has always been there, and it will be there long after this quiet night has passed. Tonight, there is nothing you need to learn. There is no test to pass, no facts to memorize, no information to hold on to tightly. Everything I am going to tell you in the minutes ahead is real, and it is verified, and it is settled knowledge, as quiet and solid as the ground beneath you. But you do not need to hold on to any of it. You can let the words wash over you like slow water, like a gentle stream that flows past while you rest on the bank. If a fact drifts away before you can catch it, that is perfectly fine. If your attention softens and you miss a sentence or two, there is no need to pull yourself back. The words are here to settle you, not to test you. They are here to paint a slow, calm picture in your mind, a picture you can rest inside, a picture that asks nothing of you in return. So let us begin with that picture, that simple image of lying beneath the night sky. But instead of thinking of the sky as a distant dome, as something far away and unreachable, try to imagine it as a ceiling that is very close as the air around you. Imagine that the stars are not tiny pinpricks in a great void, but nearby lights in a vast room, a room so large that you cannot see its walls, a room so enormous that you cannot even guess at its true size. And you are lying on the floor of that room, looking up at its softly glowing ceiling. That ceiling is not a solid surface. It is made of stars and gas and dust and light that has traveled for a very long time to reach your eyes. But you do not need to think about that travel, not yet. For now, just imagine the warmth of being inside, of being enclosed, of being held. There is a deep stillness in that image. You are not floating alone in an empty void. You are inside a structure, a real place, a place with shape and form and motion, even if you cannot feel that motion in your bones. You are inside the Milky Way, a galaxy, a word that simply means a very large family of stars, all bound together by the quiet, patient pull of gravity, and you are part of that family. The sun is part of it, the earth is part of it, your body, your breath, your slow, drifting thoughts are all happening inside it, cradled within it, as surely as a child is cradled in a blanket. There is a comfort in that thought, a comfort that comes from belonging to something so much larger than yourself. You do not need to understand it fully. You do not need to map it out or measure it. You just need to rest in the simple knowing that it is there, that it is real, and that you are inside it. The ceiling of the night sky is not a barrier between you and the universe. It is the universe, seen from the inside, a view from a window in a house so large that its walls are invisible. And you are home. You have always been home. The stars are not strangers. They are neighbors. Quiet neighbors who have been shining long before you were born, and who will keep shining long after you are asleep. Take a slow breath, and as you breathe out, let the last of the day's tension leave your body. There is nothing out there that needs your attention right now. There is only this room, this quiet, and the slow, steady presence of the galaxy turning around you. You do not need to count stars. You do not need to name them. You can just let them be there, a soft, shimmering presence in the dark, a presence that asks nothing of you. The Milky Way is not a puzzle to be solved. It is a home to be rested in. And tonight, you are resting in it, deeply, peacefully, without any effort at all. Everything I am going to share with you in the hours ahead is built on this one simple idea. You are already inside what we are talking about. We are not going on a journey outward into some distant, unfamiliar place. We are simply going to describe the room you are already in. We are going to talk about its shape, its size, its quiet motion, its gentle history. But we are going to do it slowly, softly, with no rush and no urgency. There is plenty of time. The galaxy is not going anywhere. It has been here for billions of years, and it will be here for billions more. A few hours of quiet talk will not disturb it. A few hours of restful listening will not change it. And you are allowed to drift off at any moment, to let sleep take you, to surrender to the deep, quiet pull of your own tired body. That is what this is for. So picture that ceiling again, that vast, soft ceiling of stars and darkness. Feel how close it is, how gently it presses down, not with weight but with presence. You are not exposed to the cold emptiness of space. You are wrapped inside it, tucked in, held still. The night sky is not a window onto something far away. It is the inside of your own home, a home so large that you cannot see its edges, a home so large that you cannot see its beginning, a home so quiet that you can hear your own heartbeat in the silence. And now, as you settle even deeper into the mattress, as your limbs grow heavy and your breathing slows, let that image carry you. The Milky Way is your home galaxy. You are inside it. The stars are all around you. There is nothing to fear, nothing to solve, nothing to remember. Just the slow, steady presence of a galaxy at rest, and you resting inside it. The night is long and calm, and we have only just begun. But there is no hurry. There is never any hurry. Just lie still, and let the words come, like soft rain on a roof, like a quiet voice in the dark, like the slow turning of a sky that has been turning for billions of years and will keep turning long after this night has passed, into a peaceful, dreamless sleep. The night is still around you now, and the image of that soft ceiling of stars is settling gently into your mind. You are lying inside something vast, something quiet, something that has been here long before you and will be here long after. But what exactly is this thing we are inside of? What is a galaxy, really, in the simplest and most honest terms? That is what we will sit with now, slowly and without hurry, letting the idea take shape as softly as the darkness itself. A galaxy, at its heart, is a very large group of stars. That is the simplest way to say it. But it is more than just stars. A galaxy also holds gas and dust and other matter, all of it bound together by the steady, patient pull of gravity. Imagine a great, slow whirlpool of light and material, everything held in place by an invisible force that never rushes, never hurries, never lets go. That force is gravity. The same gravity that holds you gently to your bed right now. The same gravity that keeps the Earth in its orbit around the Sun. It is the quiet glue of the universe, and it works on the very largest scales just as it works on the very smallest. Every star in the Milky Way, every cloud of gas, every speck of dust, every planet, every moon, every drifting bit of ice and rock is held within the galaxy by the mutual pull of all the other material around it. Everything is tugging on everything else, and the result is a great, slow, stable structure that has lasted for billions of years. Think of it like a city of stars, a city so large that you cannot see its edges from where you sit. In a city, there are buildings and streets and parks, all arranged in some kind of order, all connected by the ground they share. In a galaxy, the buildings are stars, the streets are the empty spaces between them, and the ground they share is the gravitational field that holds them all together. And just as a city is more than its buildings, a galaxy is more than its stars. There are the spaces between, and those spaces are not truly empty, as we will talk about later. There is gas, thin and cool, drifting between the stars. There is dust, fine as smoke, blocking and scattering the light. There are planets, too small and too dim to see from far away, circling their own home stars, just as our Earth circles the Sun. All of this together makes up a galaxy. The Milky Way is our galaxy, our home city of stars. It contains all of these things, stars, of course, in numbers so large they are hard to hold in the mind, but also planets, gas clouds, and dust, all of it bound by the mutual pull of gravity. When you look up at the night sky, every single star you see with your naked eye is a member of this same galaxy. They are not scattered randomly across the universe. They are neighbors, part of the same great structure, part of the same gravitational family. Even the faintest, most distant speck of light you can pick out on a dark night is still inside the Milky Way, still part of this one enormous collection. The universe beyond our galaxy is filled with other galaxies, other cities of stars, but they are so far away that to the naked eye they look like single, faint points of light, or they are invisible entirely, too dim for our eyes to catch without help. Now, it is important to make a gentle distinction here, because the words can sometimes blur together in a tired mind. A galaxy is not the same thing as a solar system. A solar system is much, much smaller. A solar system is one star and everything that orbits around it. The planets, the moons, the asteroids, the comets, all the smaller bits and pieces caught in that single star's gravitational hold. Our solar system has one star, the Sun, and 8 planets, along with all their moons and the various smaller bodies that circle the Sun at different distances. That is a solar system. A galaxy, on the other hand, is a collection of an enormous number of solar systems, or of stars that may or may not have planets of their own. Our solar system is just one tiny part of the Milky Way galaxy. The Sun is just one star among all the other stars, and the Earth is just one planet orbiting that one star. So there is a nesting, a layering of scale. You are on a planet which orbits a star, which sits inside a galaxy, which itself is just one of many galaxies in the wider universe. But tonight we are staying inside that middle layer, the galaxy, the great city of stars that holds our Sun and all the stars we can see. So when we say the Milky Way is a galaxy, we mean it is a vast collection of stars, gas, and dust, all held together by gravity. And the number of stars in this collection is something worth sitting with for a moment. Not because you need to memorize a figure, but because the honesty of the number itself is calming. You see, the real total number of stars in the Milky Way is not precisely known. It is not a single, fixed, agreed-upon number. It is an estimate, a careful guess based on the best measurements we can make from our position inside the galaxy. And there is something deeply peaceful about that. There is no need for a precise answer. The not knowing is not a failure. It is simply the way things are when you are trying to count grains of sand from the middle of the beach. Estimates for the Milky Way's star count commonly range from about 100 billion to 400 billion. Let those numbers sit in your mind for a moment, spelled out slowly, without any need to grasp them fully. 100 billion stars. That is the lower end of the estimate. On the higher end, some measurements suggest up to 400 billion stars. That is a wide range, and the range itself is honest, not a flaw. It reflects the real difficulty of the task. We cannot see every star in the galaxy. Many of them are too dim, too far away, or hidden behind clouds of dust. So astronomers use measurements of the galaxy's total mass, its total light output, and the way stars are distributed in the regions we can see, and from those measurements they build models that give a probable range. 100 billion to 400 billion. It is a number so large that it slips past understanding and becomes something else. Something more like a feeling, a sense of abundance, a sense of deep, quiet plenty. There is no shortage of stars. There is no scarcity of light. The galaxy is rich with them, filled with them, crowded with them in its brightest regions, and still scattered with them even in its quieter, emptier outer parts. And each of those stars, every single one, is a sun, a vast ball of hot, glowing gas, much like our own sun or different from it in 100 ways. Some are larger and hotter, blazing with blue-white light. Some are smaller and cooler, glowing with a dim, steady red. Some are very old, nearly as old as the galaxy itself. Some are very young, just recently born from the collapse of a cloud of gas. Some have planets around them, entire solar systems of their own, worlds we cannot see, but can sometimes detect through subtle, careful measurements. And all of them, all 100 billion to 400 billion of them, are moving together through space, held in the same gravitational embrace, part of the same great structure that you are part of right now. There is a quiet comfort in that number, precisely because it is not exact. If the number were fixed and certain, your mind might try to grasp it, to hold it, to file it away as a fact to remember. But the number is soft, it is fuzzy at the edges, it is an estimate, and that softness invites you to let it go. You do not need to know exactly how many stars there are. No one does. The galaxy does not need to be counted to be real. It is there, above you and around you, whether you know its exact population or not. The stars do not care if we have counted them correctly. They just keep shining, slowly, steadily, as they have for billions of years. So rest for a moment on that simple, honest definition. A galaxy is a very large group of stars, gas, dust, and other matter, held together by gravity. The Milky Way is our galaxy. It contains somewhere between 100 billion and 400 billion stars, and we do not know the exact number, and that is perfectly fine. The not knowing is part of the calm. The galaxy is not a problem to be solved. It is a home to be rested in, and you are resting in it now, lying still in the dark, part of a structure so large that even its basic count of stars is something we can only estimate, only approach, never fully pin down. Let that softness carry you for a while. The numbers do not need to be sharp. The edges do not need to be clear. The galaxy is a place of gentle, enormous scales, and the human mind is not built to hold those scales in full detail. It is built, instead, to feel them, to sense them, to rest in the awe of them, without needing to measure every part. Like standing on the shore of a vast ocean, you do not need to count the drops of water. You just need to feel the presence of the sea, the sound of the waves, the salt in the air. The galaxy is like that ocean, a sea of stars instead of water, and you are floating in it, gently, without effort, without any need to understand it all. The gas and dust between the stars are part of this too. The galaxy is not just the bright points of light. It is also the thin, diffuse material, that fills the spaces between them. This material is so thin that in most places it would seem like a perfect vacuum to us, emptier than anything we can create on Earth. But over the vast distances of the galaxy, it adds up. It forms clouds, some of them dense and dark, some of them glowing faintly with the light of nearby stars. These clouds are the raw material from which new stars are born, and we will talk about them more in a later section. For now, just know that they are there, part of the galaxy's substance, part of its quiet, ongoing life. And you are inside all of this. The bed you are lying on, the room around you, the building, the city, the country, the continent, the planet, all of it is inside this galaxy. The Milky Way is not somewhere else. It is here. It is now. It is the environment in which your entire life takes place, even if you never think about it during the busy hours of the day. But now, in the quiet of the night, with your eyes closed and your breathing slow, you can let that awareness settle over you like a soft blanket. You are inside a galaxy. A galaxy is a great collection of stars, gas, and dust, held together by gravity. And the number of stars in your home galaxy is so large that it is only known as a range, a gentle, honest estimate, somewhere between 100 billion and 400 billion. There is nothing to memorize, there is nothing to solve. Just the quiet presence of 100 billion suns, maybe more, all around you in the dark, all moving in their slow, patient orbits, all part of the same great family, and you are part of it too. Your body is made of atoms that were forged in earlier generations of stars, atoms that drifted through the galaxy for billions of years before coming together to form the Earth, and life, and you. That is a fact we will return to later, but for now it is enough to know that you belong here. You are not a stranger in the galaxy. You are a child of it, made from its material, living inside its embrace, resting now in its quiet, steady presence. The night stretches on, slow and calm, and we have only just begun to describe the room you are in. The shape of that room, the form of the galaxy itself, is what we will turn to next. But there is no hurry. Let the definition settle. A galaxy is a very large group of stars, gas, dust, and other matter, held together by gravity. The Milky Way is our galaxy. You are inside it. And that is enough for now, more than enough, as you drift deeper into the stillness, carried by the slow turning of 100 billion stars. You are still here, still resting, still carried gently by the slow turning of 100 billion suns. And now that we have sat for a while with what a galaxy is, we can begin to picture its shape, the form of this enormous room you are lying inside. Because the Milky Way is not just a random scatter of stars. It has a shape, a structure, a form that you can hold in your mind like a smooth, quiet image, something to rest your thoughts on as the night deepens around you. The Milky Way is what astronomers call a barred spiral galaxy. That is a term we can unpack slowly, piece by piece, until it feels familiar and comfortable, like the description of a room you know well. A spiral galaxy is one that has a flat, disc-like shape, something like a very thin plate, with long, curving arms of stars and gas winding outward from the center. The word spiral simply means that these arms curve around in a pattern that reminds us of a whirlpool, or the way water circles a drain, or the way cream swirls in a cup of coffee. It is a soft, curving shape, not sharp or angular, a shape that suggests slow motion even when it is standing still in a picture. And our galaxy has that shape. If you could float high above the Milky Way and look down on it, you would see a great, glowing disk with bright, curving arms spiraling out from the middle, the whole thing turning slowly in the dark. But there is more to the shape than just the spiral. The Milky Way is a barred spiral galaxy. The word barred here does not mean blocked or forbidden. It means something much simpler. It means that running through the center of the galaxy, there is a straight, bar-shaped concentration of stars, a long, bright line of stellar light that cuts through the middle, like a rod through the center of a pinwheel. The spiral arms do not start directly from the very center point. Instead, They unwind from the ends of this straight bar. So if you picture the galaxy from above, you would see a bright, elongated bar of stars in the middle, and from each end of that bar, the spiral arms would curve outward, sweeping around in a gentle, glowing arc. It is a lovely shape, balanced and calm, a shape that has been seen in many other galaxies across the universe. Galaxies that we can photograph from outside because they are far away and we can see their full form. But here is something quiet and patient to sit with. We have never seen our own galaxy from the outside. We have never sent a camera high above the Milky Way to take a photograph of its full shape. Every image you have ever seen of the Milky Way as a complete spiral galaxy is an artist's drawing, a careful model built from evidence, or a photograph of a different galaxy that astronomers think looks very much like our own. We are inside the Milky Way, and that means we have to map its shape from the inside out, which is a slow and careful task. It is a little like trying to draw the shape of a huge forest while standing deep inside it, among the trees. You can see the trees around you. You can measure their distances and their positions. You can look for patterns in the way they are arranged, but you cannot step back and see the whole forest at once. You have to build the picture piece by piece, using clues and measurements and patient, repeated observations. So the shape of the Milky Way is not something we have seen directly. It is something we have deduced, something we have built up over many decades of careful work. Astronomers have measured the distances to stars. They have mapped the positions of gas clouds. They have traced the spiral arms by looking for bright young stars, and the glowing nebulae where stars are born, because those tend to cluster along the arms. They have used radio waves and infrared light to peer through the dust that blocks visible light. And from all of these clues, they have pieced together a model of what the galaxy must look like from the outside. The model is not perfect. There are details we are still unsure about, but the broad picture is settled and calm. The Milky Way is a barred spiral galaxy, a flat disk with a bright bar across its middle and long, curving arms, winding outward from the ends of that bar. Now, let us describe the parts of this shape more slowly, so you can picture them one by one, like building a quiet image in a darkened room. First, there is the disk. The disk is the flat, thin part of the galaxy, the part that contains most of the stars and nearly all of the gas and dust. It is very wide and very thin, like a pancake or a crepe, stretched out across an enormous distance. The disk is where the spiral arms live. It is where new stars are born, in the dense clouds of gas that collect along the arms. It is where you find the bright, hot, young stars that glow blue-white, and the glowing nebulae they illuminate. The disk is the active, busy part of the galaxy, though busy is a word we use gently here, because even the busiest parts of the galaxy move on timescales far too slow for a human mind to perceive in real time. The disk rotates. The stars in it orbit the center, and the whole thing turns like a great, slow wheel in the night. Next, there is the bulge. The bulge is a thicker, rounder concentration of stars at the very center of the galaxy, sitting in the middle of the disk like the yolk in the center of a fried egg. The bulge is made mostly of older stars, stars that formed long ago, when the galaxy was young. They are packed more densely here than in the disk, and their collective light creates a bright, warm glow at the heart of the Milky Way. The bulge is not perfectly round. Because the Milky Way is a barred spiral, the bulge is somewhat elongated, stretched into that bar shape we talked about, a long, straight concentration of stars that runs through the center. So if you picture the galaxy from above, you do not see a perfect circle of light in the middle. You see a bright, stretched oval, a bar, and then the spiral arms curving away from its ends. Beyond the disk and the bulge, there is a much larger, fainter region called the halo. The halo is a roughly spherical cloud of old stars, globular clusters, and dark matter that surrounds the entire galaxy. It is much larger than the disk and much more diffuse, with stars scattered very thinly through it. You do not need to picture the halo in detail right now. It is enough to know that it is there, a faint, quiet envelope around the bright disk, like a soft glow around a candle flame. So the shape of the Milky Way, the shape you are resting inside, is this: a thin, flat disk, about 100,000 light-years across, with a bright bar of stars running through its center and long, curving spiral arms unwinding from the ends of that bar. Around the disk is a thicker bulge of older stars, and around it all is a vast, faint halo. That is the room you are in. That is the shape of your home galaxy. But let us sit for a moment with that number, the size of the disk. The estimated diameter of the Milky Way's disk is commonly cited as about 100,000 light-years. That is a number we should take apart gently, because it carries real uncertainty, and that uncertainty is part of the calm. A light-year, as we will talk about more in the next section, is the distance light travels in 1 year. Light moves very fast, about 300,000 kilometers per second, a speed so great that it can circle the Earth more than 7 times in a single second. In 1 year, light covers a distance of about 9.5 trillion kilometers. That is 1 light-year, and the Milky Way's disk is about 100,000 of those light-years across. That means if you could travel at the speed of light, it would take you 100,000 years to cross from one side of the disk to the other. But the number 100,000 is not a fixed, certain measurement. It is an estimate, based on measurements of the stars and gas at the outer edges of the disk, and those edges are not sharp. The disk does not end abruptly, like the edge of a table. It fades out gradually, the stars becoming thinner and thinner, the gas more and more diffuse, until there is no clear line where the galaxy stops and the empty space between galaxies begins. So astronomers have to choose a point at which to say, here is the edge, more or less. Different studies, using different methods, have given slightly different numbers. Some measurements suggest the disk might be a bit larger, perhaps 120,000 light-years across. Others suggest it might be somewhat smaller. The number 100,000 is a good, round, widely accepted estimate, but it is not a hard fact. It is a gentle approximation, and that gentleness is something to rest in. The galaxy does not need to have a precise diameter. It is not a solid object with sharp edges. It is a soft, fading structure, a gathering of stars that gradually thins out into the void. And that softness, that lack of a hard boundary, is part of its quiet beauty. The same softness applies to our understanding of the spiral arms. We know there are several major arms, but their exact number, their exact paths, and their exact names are still matters of study and debate. The usual picture includes 2 main arms that unwind from the ends of the central bar, sometimes called the scutum centauris arm and the Perseus arm, along with several smaller arms and spurs. But the details are not something you need to hold on to. What matters is the overall form, the gentle, curving spiral, the sense of slow, ordered motion. You are inside a great, turning pinwheel of stars, a shape that has been sculpted by gravity over billions of years. And that shape is beautiful in its simplicity, even if the exact details remain a little fuzzy at the edges. So as you lie here in the dark, you can hold that image in your mind. A flat, thin disk of stars, about 100,000 light-years across, though the edges are soft and uncertain. A bright bar of stars running through the center, spiral arms curving outward from the ends of that bar, winding through the disk like slow, glowing rivers of light. A thick bulge of older stars in the middle, and a vast, faint halo surrounding it all. That is the Milky Way. That is the shape of the room you are in. And you are somewhere inside that disk, somewhere off to one side, far from the center, tucked into one of the spiral arms. Where exactly you sit, and what it means to sit inside a spiral arm, is something we will turn to next. But there is no hurry. The shape is here for you to rest in, a quiet picture behind your closed eyes, a soft, turning wheel of stars that holds you gently in its motion. Let it turn, let it carry you. The night is long and the galaxy is patient, and you have all the time you need to drift a little deeper, held by the slow, curving arms of your home. The shape of the galaxy is resting in your mind now, a soft, turning wheel of stars, a barred spiral disk with its gentle, curving arms. And you are somewhere inside that disk, not at the center, not at the very edge, but tucked into one of those spiral arms, a little more than halfway out from the middle. This is where we will sit for a while now, in this quiet neighborhood of the galaxy, this place we call home. The Sun and all its planets, including the Earth, including you, sit inside one of the spiral arms of the Milky Way. We are not in the bright, dense bulge at the center. We are not in the faint, scattered halo that surrounds the disk. We are in the disk itself, inside one of the arms, moving along with all the other stars and gas and dust that make up this part of the galaxy. And the arm we live in has a name. It is often called the Orion Arm, or sometimes the Orion Spur, because it is not one of the two largest, most prominent arms. It is a smaller branch, a spur that branches off from a larger arm or sits between two of the major arms, depending on how you map the spiral structure. The names of the larger arms are not important to hold on to right now, but they are there, quiet and steady, in the background of our understanding. Two of the most well-documented major arms are the Perseus Arm, which lies farther out from the center than we do, and the Scutum Centaurus Arm, which lies closer in toward the center. The Orion Arm, our arm, sits between them, a smaller lane of stars and gas, a quieter stream within the greater river of the galaxy. Some maps show it as a spur that branches off from the Perseus Arm. Others show it as its own smaller, distinct arm. The exact mapping of the spiral structure is still a matter of study and gentle debate, and that uncertainty is part of the calm. We know the broad outlines, but the fine details remain soft, and that softness is something we can rest in. What matters is that we are here, in this arm, at a particular distance from the center. The Sun's distance from the galaxy's center is estimated at roughly 26,000 light-years. That is a number that deserves a slow, careful unpacking, because a light-year is a measure that can feel abstract until we sit with it for a moment. So let us sit with it now, quietly, without hurry. A light-year is the distance that light travels in 1 year. Light moves incredibly fast. In 1 second, a beam of light travels about 300,000 kilometers. That is far enough to circle the Earth more than 7 times in a single second. In 1 minute, light travels about 18 million kilometers. In 1 hour, it travels more than 1 billion kilometers. And in 1 full year, traveling at that same constant steady speed, light covers a distance of about 9.5 trillion kilometers. That is 1 light year. It is a measure of distance, not time, though the name can sometimes confuse a tired mind. A light year is how far light goes in a year. And the center of the Milky Way is about 26,000 of those light years away from us. Let that number settle, 26,000 light years. If you could travel at the speed of light, which nothing with mass can ever do, it would take you 26,000 years to reach the center of the galaxy. That is longer than the entire span of recorded human history, many times over. The light that reaches our telescopes from the central bulge of the Milky Way began its journey 26,000 years ago, when ice sheets still covered much of the northern hemisphere, when our ancestors were painting on cave walls, when the world was a very different place. And that light has been traveling ever since, crossing the vast, quiet spaces of the galactic disk, until it finally arrived here, at this moment, to be caught by a mirror or a lens or an eye, looking up into the dark. We are far from the center, not at the edge, but far. The galaxy stretches on for tens of thousands of light years beyond us, out into the thinner, sparser regions of the outer disk. But we are also far from the center in the other direction. We sit in a middle distance, a quiet suburb of the galactic city, far enough from the dense, crowded core that the night sky is not blazing with the light of 1 million nearby suns, but close enough that we can still see the bright band of the Milky Way stretching across the sky, the combined glow of billions of distant stars in the disk. Now, what does it mean to sit inside a spiral arm? This is something worth understanding gently, because the words spiral arm can conjure an image that is not quite right. A spiral arm is not a solid structure, like the arm of a statue or the branch of a tree. It is not a fixed, permanent collection of stars that moves through the galaxy as a single unit. Instead, a spiral arm is a region of denser gas and dust, a region where new stars are being born more actively, a wave of star formation that moves through the disk. Think of it like a slow traffic jam on a long, open highway. The cars in the jam are not the same cars forever. Cars enter the slow patch from behind, move through it, and then exit out the front, while the jam itself persists as a pattern. The stars in a spiral arm do something similar. They drift into the arm, spend time there, and eventually drift out again, while the arm itself remains as a region of higher density and brighter, younger stars. So the Sun is currently inside the Orion Arm, moving along with the general flow of stars in the disk. We have been in this arm for some time, and we will eventually drift out of it, many millions of years from now. The arm itself is not a permanent address. It is a neighborhood we are passing through, a region of slightly denser gas and slightly more active star formation. The young, bright stars that light up the arm are born there because the denser gas clouds in the arm collapse under gravity to form new stars. Those stars illuminate the surrounding gas, making the arm glow more brightly than the spaces between the arms. That is why spiral arms are visible in other galaxies. They are regions of active star formation, traced out by bright, hot, young stars and the glowing nebulae they create. In the spaces between the arms, the gas is thinner, star formation is slower, and the light is dimmer. The Orion Arm, our arm, contains many of the bright stars and nebulae we can see from Earth with the naked eye or with small telescopes. The Orion Nebula, which we will talk about later, is one of those stellar nurseries, a place where new stars are forming right now within our own spiral arm. The bright stars of the constellation Orion, which give the arm its name, are also part of this region, young, hot stars that light up the gas around them. When you look up at the night sky and see the familiar shape of Orion, you are looking at a piece of our own spiral arm, a piece of the neighborhood we are drifting through. And so here you are, on a planet, orbiting a star, inside a spiral arm, inside the disk of a barred spiral galaxy, about 26,000 light-years from the center. You are not at the center of anything. The Sun is not at the center of the galaxy. The Earth is not at the center of the solar system, and that is not a demotion or a disappointment. It is just a quiet fact, a fact that places you in a particular, peaceful location within a vast and beautiful structure. You are here, in this arm, at this distance, and the view from here is what it is. The night sky looks the way it does because of where we sit. The band of the Milky Way appears as a band because we are inside the flat disk, looking out through it. When you look along the plane of the disk, you see many stars stacked up along your line of sight, so many that their light blends together into a milky glow. When you look up or down, out of the plane of the disk, you see fewer stars, and the sky is darker. That is the view from inside a flat disk, and it is our view, the view from this particular arm, this particular distance, this particular quiet neighborhood in the galaxy. There is a comfort in knowing where you are, not in the sense of a precise address with a street number and a zip code, but in the sense of a location, a placement, a sense of being somewhere real within a larger whole. You are in the Orion Arm, a spur of the Milky Way's spiral structure, about 26,000 light-years from the galactic center. That is your location in the galaxy, and it is a location you share with every human who has ever lived, with every animal, every plant, every mountain and ocean and grain of sand on this planet. We have all been here, in this arm, moving together around the center, for the entire history of our species and long before. The distance of 26,000 light-years is not a number you need to hold on to tightly. It is an estimate, like so many of the numbers we sit with tonight. Some measurements place the distance a little closer, at about 25,000 light-years. Others place it a little farther, at about 27 or 28,000. The exact number is still being refined, still being measured with greater and greater precision over time. And that gentle uncertainty is not a flaw. It is a reflection of the real difficulty of measuring distances across the galaxy from our position inside it. We cannot stretch a tape measure to the center. We have to use indirect methods, measuring the positions and motions of stars, using standard candles like certain types of variable stars whose true brightness we know, building up a picture from many overlapping lines of evidence. The result is a number that is known reasonably well, but not perfectly, and that is enough. We know we are about 26,000 light-years from the center, give or take a few thousand. We know we are in the Orion Arm. We know we are far from the center, but not at the very edge. That is enough to rest with. So let yourself rest with that location now. You are here, in this arm, at this distance from the center. The stars you see at night are your neighbors in the arm, some closer, some farther. The dark spaces between them are the gaps between the stars, the thinner regions where the gas and dust are less dense. The whole arm is moving, drifting, turning around the center in a slow, patient orbit, and you are moving with it, carried along as effortlessly as a sleeping child carried in a parent's arms. You do not feel the motion, you have never felt it, but it is real, and it is happening right now as you lie still in the dark. The motion of the sun, the motion of the earth, the motion of the arm, the motion of the whole great disk turning in the night. We will talk about that motion next, about the slow, vast orbit that carries us around the center, and about the even larger motions that carry the whole galaxy through space. But for now, just be here, in this place, at this quiet distance from the bright, crowded center. You are in the Orion Arm, about 26,000 light-years from the galactic core. That is where you are, and that is enough. The night holds you there, still and calm, in your small, peaceful corner of the Milky Way. You are resting now in your small, peaceful corner of the Milky Way, in the Orion Arm, about 26,000 light-years from the bright, crowded center, and the night is very still around you. The room is quiet. Your body is heavy against the mattress. Nothing seems to be moving at all. But beneath that stillness, beneath the quiet of the night, there is motion. There is always motion. The galaxy is not a frozen sculpture of stars. It is a living, turning thing, a slow dance of gravity and momentum that has been going on for billions of years. And you are part of that dance, even now, even as you lie perfectly still. The sun orbits the center of the Milky Way. That is the first and simplest motion to hold in your mind. Just as the Earth orbits the sun itself orbits the center of the galaxy. It is the same principle, the same quiet pull of gravity, just scaled up to an almost unimaginable size. The center of the Milky Way contains an enormous amount of mass, the dense bulge of stars, the central bar, and at the very heart, the supermassive black hole we will talk about soon. All of that mass exerts a gravitational pull on everything in the galaxy, including our sun, and so the sun moves, tracing out a vast, nearly circular path around the galactic center, carrying the Earth and all the other planets along with it. You are on that moving path right now. The bed you are lying on is on the Earth. The Earth is orbiting the sun, and the sun is orbiting the galaxy. So even in your stillness, you are moving. You are moving around the Earth's axis, spinning once a day. You are moving around the sun, completing a full orbit once a year. And you are moving around the galaxy on a journey so long and so slow that a single human lifetime registers only the tiniest fraction of its progress. But the motion is real. It is steady. It has been going on since before you were born, since before the Earth was born, and it will continue long after. One full orbit of the sun around the galaxy takes an enormous amount of time. The current best estimate is about 220 million years. That number, 220 million years, is sometimes called a galactic year or a cosmic year. It is a unit of time so large that it slips past our usual sense of scale and becomes something almost abstract. To put it gently into context, the entire history of human civilization, from the first cities to this present night, spans only about 6,000 years. That is a tiny sliver of a single galactic year. The dinosaurs appeared on Earth about 230 million years ago, which is just over 1 galactic year ago. When the Sun last completed a full orbit of the Milky Way, the first dinosaurs were just beginning to walk the Earth. The continents were arranged differently then, joined together into a single supercontinent. The plants and animals were unlike anything alive today, and the Sun, in its quiet, patient way, has been making that same round trip ever since, over and over, for billions of years. The entire solar system has completed only a small number of these galactic years since it formed. The Earth and the Sun are about 4.5 billion years old. If you divide that by 220 million years per orbit, you get roughly 20 orbits, 20 times around the entire galaxy. That is all. In the entire history of our solar system, we have circled the Milky Way only about 20 times. That number is so small and so large at the same time, a handful of slow, grand circuits, each one taking longer than the entire span of complex life on Earth. There is a deep peace in that. The galaxy turns so slowly, so patiently, that even the oldest things in our solar system have barely begun to explore its full circumference. We are still, in a sense, newcomers here. The Sun has been around the block only 20 times. There is so much more journey ahead. The speed at which the Sun moves on this orbit is also worth sitting with, though the number can feel startling if you try to hold it too tightly. The Sun's orbital speed is estimated at roughly 230 kilometers per second. Let that number roll out slowly. 230 kilometers per second. In the time it takes you to breathe in and breathe out, the entire solar system has moved thousands of kilometers through the galaxy. But speed is a strange thing to feel, because we do not feel it at all. There is no wind in space, there is no rush of air, no sense of acceleration, no hint of motion in the quiet of your room. You are moving at more than 200 kilometers every single second, and yet you feel perfectly, completely still. That is because the motion is constant and smooth, and everything around you is moving at the same speed, in the same direction, so there is no relative change to detect. It is like being on a perfectly smooth train with the windows closed, gliding along at a steady pace. You know you are moving, but inside the carriage, everything is calm and still. This motion, this orbit around the galactic center, is not the only motion the galaxy makes. There is another, larger layer of movement, something to hold in the back of your mind as you drift. The Milky Way itself is moving through space, relative to other galaxies. Just as the Sun orbits the center of the Milky Way as a whole is moving relative to the other galaxies around it. The universe is expanding, and on the largest scales, galaxies are being carried apart by that expansion. But within our local neighborhood, gravity still holds sway. The Milky Way and the Andromeda Galaxy, and the smaller galaxies in our group, are all moving relative to one another, drawn together by their mutual gravitational pull. The Milky Way is not sitting still in space. It is moving, drifting, falling through the cosmos on its own slow, silent trajectory. And the motion does not stop there. The local group of galaxies, the small cluster that includes the Milky Way and Andromeda, is itself moving relative to larger structures, drawn toward the Virgo cluster, a much larger gathering of galaxies, and beyond that, toward the even vaster structures that shape the universe on the grandest scales. Layer upon layer of motion, each one slower and more gradual than the last, each one carrying the one before it. You are spinning around the Earth's axis. You are orbiting the Sun. The Sun is orbiting the galactic center. The galaxy is moving through the local group. The local group is moving toward Virgo, and all of it, all of these motions together, is happening right now, in this moment, as you lie with your eyes closed and your breathing slow. But there is no need to track all of these layers. They are here to be felt, not to be followed. The important motion, the one we are sitting with tonight, is the orbit of the Sun around the Milky Way. That is the motion that places you in the great turning wheel of the galaxy, the motion that makes you a traveler on a long, slow journey through the stars. And the pace of that journey is so slow, so gentle, that it can never be rushed. A galactic year, 220 million years, is a number that stretches out beyond any human urgency. There is no deadline. There is no schedule. The sun will complete its orbit in its own time, and you, riding along on this small, warm planet, are carried with it in perfect, effortless stillness. Imagine, if you like, the path of the sun as a great, slow circle around the bright center of the galaxy. Picture the disk of the Milky Way from above, that barred spiral shape we talked about earlier. The sun is out in the disk, in the Orion Arm, about halfway from the center to the visible edge. And it is moving, along with all the other stars in its neighborhood, in a roughly circular orbit, bobbing slightly up and down through the plane of the disk as it goes. The orbit is not a perfect circle. It is slightly elliptical, slightly wobbly, perturbed by the gravity of other stars and gas clouds and spiral arms. But on the largest scale, it is a steady, patient loop, a loop that takes 220 million years to close. The last time the sun was in this part of its orbit, this particular region of the galaxy relative to the center, the Earth was a very different place. The first dinosaurs were just appearing. The first mammals were small, shrew-like creatures scurrying through the undergrowth. The first birds were learning to fly. The continents were locked together in a single landmass called Pangaea, which was just beginning to split apart. The Atlantic Ocean did not yet exist. The Himalayas had not yet risen, and the sun, carrying its young cargo of life, sailed on through the galaxy, passing through regions of denser gas, passing near other stars, witnessing the slow, majestic turn of the spiral arms. None of it hurried, none of it rushed, and now, one galactic orbit later, here we are. The dinosaurs have come and gone, the continents have drifted apart, the mammals have risen and diversified. Human beings have appeared, built cities, written books, sent telescopes into space, and through all of that, the sun has been moving, steady and silent, completing its vast circuit around the galaxy. There is a comfort in this motion, a comfort that comes from being part of something so much larger than yourself. You are not adrift in a chaotic, random universe. You are on a journey with a path and a rhythm, a journey that has been underway for 4.5 billion years and will continue for billions more. The sun is not wandering aimlessly. It is orbiting, following the gentle curve of gravity, held in the embrace of the galaxy's mass. And you are held in that same embrace, carried along in the dark, moving without effort, moving without sound, moving through the quiet, star-filled night of the galaxy. The speed of this motion, 230 kilometers per second, is a number that can sound fast to our earthbound ears. But speed in space is relative, and what matters is not the number itself, but the scale of the journey. 230 kilometers per second is fast enough to cross the entire United States in about 20 seconds. It is fast enough to circle the Earth in about 3 minutes. But the galaxy is so vast that even at this speed, the sun needs 220 million years to complete a single lap. The scale swallows the speed. The distance is so immense that even a blistering pace becomes a slow, patient crawl when measured against the size of the Milky Way. The stars you see in the night sky, the nearest ones, are also moving, also orbiting, at similar speeds, in similar directions. They are fellow travelers on this great roundabout, each one on its own slightly different path, each one bound by the same gravity, each one taking its own time to complete the circuit. And so, as you lie here in the dark, you can let yourself feel, just faintly, the motion you are part of. Not as a physical sensation because there is nothing to feel, but as an image, a quiet picture in your mind. You are on a planet, orbiting a star, moving around the center of the galaxy. The journey is long and slow and calm. There is no rush, there is no destination. The orbit simply continues, as it has for billions of years, as it will for billions more. You are a passenger on a quiet ship, sailing through the sea of stars, and the night around you is the gentle darkness of that sea, holding you, carrying you, rocking you softly towards sleep. The motion never stops, but you do not need to keep track of it. You can simply let it be there, a deep, steady rhythm beneath the stillness, a rhythm as old as the galaxy itself. The rhythm of the galaxy is deep and steady beneath the stillness, a rhythm as old as the galaxy itself. And at the heart of that rhythm, at the very center of the great turning wheel, lies a place of density and mystery. We have talked about the shape of the Milky Way, the flat disk and the curving spiral arms. We have talked about where we sit, far out in the Orion Arm, 26,000 light-years from the center. And now we turn our attention, gently and without hurry, toward that center itself, toward the dense, bright bulge of stars and the quiet, invisible presence that sits at its core. The central bulge of the Milky Way is a dense, roughly spherical cluster of stars near the middle of the galaxy. If the disk is a thin, flat pancake of stars, the bulge is a thick, round ball of stars sitting in the center of that pancake. It is packed with stars, many more stars per cubic light-year than in our quiet suburban arm. The stars in the bulge are mostly older, many of them as old as the galaxy itself, formed in the early days when the Milky Way was first coming together. They are crowded together, their light blending into a warm golden glow that can be seen from Earth as the brightest part of the Milky Way's band across the sky. From our position in the disk, we cannot see the bulge directly with visible light in all its detail. There are vast clouds of dust between us and the center, dust that blocks and scatters visible light. The dust is not thick like a wall, but over 26,000 light-years it adds up. It dims the light of the central bulge by many times, so that if we could see it without the dust in the way, the center of the galaxy would blaze in our night sky as bright as the full moon or even brighter. Instead, it appears as a softer glow, a thickening of the Milky Way's band in the direction of the constellation Sagittarius, where the center lies. To study the bulge in detail, astronomers use other kinds of light that can pass through dust more easily, infrared light, which has longer wavelengths than visible light, and radio waves, which have even longer wavelengths still. With these tools, we can peer through the dust and map the shape of the bulge, the distribution of its stars, and the motions of everything swirling around the very middle. The bulge is a crowded place, but it is not a violent one. It is simply dense, a gathering of old stars moving in their own slow orbits around the center. Some of those orbits are more random, more tilted and elliptical than the neat, circular orbits of the disk. The bulge is a more chaotic environment, gravitationally speaking, with stars passing close to one another, tugging on each other, creating a complex dance of motion. But even this complexity is slow and patient, unfolding over millions of years. From our distant vantage point, it is a quiet, steady glow, a warm heart at the center of our galaxy. And at the very, very center of that bulge, at the exact gravitational center of the Milky Way, there is something else. Something that gives off no light of its own, but whose presence can be deduced from the motions of the stars around it. A supermassive black hole. It has a name, Sagittarius A star, often written as Sagittarius A with an asterisk, pronounced simply as Sagittarius A star. The name comes from its location in the constellation Sagittarius, and the A star designation marks it as the brightest radio source in that part of the sky, the point at the very center of the galaxy. Now, a black hole is a term that can sound dramatic or frightening to the waking mind. But here, in the quiet of the night, we can approach it calmly and plainly, without any need for excitement or fear. A black hole is simply a region of space where gravity is so strong that nothing, not even light, can escape from it. That is the plainest definition. Gravity is the force that pulls things together. The more mass you have in one place, the stronger the pull. In a black hole, so much mass is packed into such a small space that the gravitational pull becomes overpowering. There is a boundary around the black hole called the event horizon. Once something crosses that boundary, it cannot come back out. The gravity is simply too strong. Even light, the fastest thing in the universe, cannot climb back out past the event horizon. That is why it is called a black hole. It does not give off any light. It is dark, perfectly dark, a place where gravity has the final say. But a black hole is not a vacuum cleaner. It does not reach out and pull things in from across the galaxy. Its gravity works just like the gravity of any other object with mass. If the Sun were somehow replaced by a black hole of the exact same mass, the Earth would continue to orbit it in exactly the same way, at exactly the same distance, though it would become very cold and dark. A black hole is dangerous only if you get very, very close to it, and we are not close to Sagittarius A star. We are 26,000 light-years away. That is a safe distance, a distance so vast that the black hole's gravity affects us no more than the gravity of any other 4 million solar mass object at the center of the galaxy would. The Sun orbits the center because of all the mass there, the mass of the bulge, the mass of the bar, the mass of the black hole, all combined. The black hole is a tiny, tiny fraction of the galaxy's total mass, about 4 million solar masses out of a galaxy that contains the mass of perhaps 1 trillion suns when you include the dark matter halo. It is significant at the very center, but it is not the master of the galaxy. The galaxy is held together by the collective gravity of all its parts, not by the black hole alone. The mass of Sagittarius A star is estimated at about 4 million times the mass of the Sun. Let that number sit quietly for a moment. 4 million suns, all packed into a space smaller than the orbit of Mercury. That is the density we are talking about. The event horizon, the point of no return, is about 12 million kilometers across, which is about 1/5 of Mercury's orbital distance. Inside that boundary, the mass is so concentrated, the gravity so intense, that nothing can escape. But outside it, the black hole is just another source of gravity, a very massive one, but one that obeys the same physical laws as everything else. For decades, Sagittarius A star was known only indirectly. Astronomers tracked the orbits of bright stars near the galactic center, stars that whipped around an invisible point at incredible speeds. By measuring those orbits, they could calculate the mass of the object the stars were orbiting. There was no other explanation for the numbers they got. A mass of about 4 million suns, packed into a volume so small that it had to be a black hole. There was simply nothing else in known physics that could fit the data. So the existence of the supermassive black hole at the center of the Milky Way became settled, quiet knowledge, a fact as solid as the Earth beneath you, even though the thing itself could not be seen. And then, in the last few years, we did see it, or rather, we saw its shadow. In 2019, an international collaboration of radio telescopes called the Event Horizon Telescope produced the first direct image of the environment around Sagittarius A star. The image showed a glowing ring of hot gas surrounding a dark central shadow, the shadow of the event horizon itself. The light in the ring comes from gas that is swirling around the black hole, heated to billions of degrees as it spirals inward. The dark center is the black hole's shadow, the place where light cannot escape. The image matched the predictions of general relativity, Einstein's theory of gravity, with remarkable precision. It was a confirmation of something already known, a quiet verification, a settled piece of knowledge made visible. There was no drama in the discovery. It was the culmination of years of careful, patient work, the kind of work that builds slowly toward a result that is both profound and, in its own way, calming. So the center of the Milky Way is not a place to fear. It is a place of quiet density, a bright bulge of old stars, and at its heart, a dark, massive presence that has been there for billions of years, doing what black holes do, simply existing, holding the center steady with its gravity, anchoring the orbits of the stars that swirl around it. The black hole is not consuming the galaxy. It is not growing in any way that threatens us. The gas and dust near the center are sparse, and the black hole is in a relatively quiet phase, not actively feeding on large amounts of material. It is, for now, a sleeping giant, a quiet heart beating slowly in the dark. You can picture the center of the galaxy, if you like, as a warm, golden glow, the combined light of millions of old stars packed closely together. And at the very middle of that glow, invisible to the eye, is a small, dark point, a place where gravity is king, where the rules of everyday physics bend and stretch. But that point is far away, impossibly far, 26,000 light-years from where you lie. Its influence does not reach you. Its gravity is just one part of the great gravitational field that holds the galaxy together. You are safe from it, as safe as a fish in a coral reef is safe from the deep ocean trench miles away. The black hole is there, it is real, it has been seen and measured and confirmed, but it is not a danger. It is just another part of the galaxy, a part that happens to be very dense and very dark and very quiet. The stars that orbit close to Sagittarius A star, the ones that allowed astronomers to measure its mass, move at incredible speeds. Some of them complete an orbit in just a few years, compared to the Sun's 220 million years. They are the dancers closest to the center, whirling around the invisible point at the heart of the galaxy. Their motion is a testament to the mass they orbit, a visible demonstration of the black hole's gravitational pull. They are like leaves caught in a whirlpool, circling around and around, their paths determined by the shape of space-time near the event horizon. And their orbits, tracked patiently over years and decades, have painted a picture of the center that is as detailed and as confident as any other part of modern astronomy. There is a peace in knowing that the center exists, that the galaxy has a heart, that the heart is dense and dark and quiet. The Milky Way is not a random scatter of stars. It has a structure, a center, a gravitational anchor. That anchor is a supermassive black hole, one of many that sit at the centers of galaxies across the universe, and like the others, it simply sits, holding its place, part of the slow, steady machinery of the cosmos. You do not need to think about it too much. You do not need to imagine falling into it or wonder what happens inside it. Those are questions for another time, or for no time at all. Tonight, the black hole is just a quiet presence, a dark jewel at the heart of the galaxy, far away and peaceful, part of the deep, steady rhythm that carries you toward sleep. The bulge and the black hole are the dense core of the galaxy, the place where the greatest concentration of mass lives. But the galaxy is more than its core. It is filled, from center to edge, with stars of every kind, stars of different sizes and colors and ages, stars that are born and live and die in a slow, natural rhythm. We will turn to those stars next, to the ordinary scattered suns that fill the disk and the arms, the stars that make up the vast majority of the galaxy's population. But for now, let the center rest in your mind as a quiet, golden glow, with a dark point at its middle, far away and still, holding the galaxy together in its patient, invisible embrace. The night is deep, and the heart of the Milky Way beats softly in the darkness, a slow pulse that has been beating for 13 billion years and will keep beating long after this night has passed into a peaceful, dreamless sleep. The heart of the galaxy beats softly in the darkness, far away and still. But the galaxy is more than its heart. It is filled, from the dense center to the thinnest outer edges, with stars, stars of every kind, every size, every color, every age. The Milky Way is a vast collection of stars, somewhere between 100 billion and 400 billion of them, as we sat with earlier. And now we can zoom back out from the center, back out to the disk and the arms, and look more closely at the stars themselves, at the ordinary scattered suns that make up the great majority of the galaxy's population. Stars in the Milky Way vary enormously. That is the first and simplest thing to know. They are not all the same. They come in a wide range of sizes, from small, dim stars only a fraction of the sun's mass, to enormous, blazing stars that are dozens or even hundreds of times more massive than the sun. They come in a range of temperatures, from cool stars that glow a deep, dull red, to hot stars that burn with a fierce blue-white light. They come in a range of ages, from stars that formed only a few million years ago, barely an infant by galactic standards, to stars that are nearly as old as the galaxy itself, 13 billion years old, ancient and stable and slow. The variety among stars is as rich as the variety among trees in a forest, or fish in a coral reef. And yet all of them, from the smallest to the largest, are governed by the same basic physics, the same balance between the inward pull of gravity and the outward push of energy from nuclear fusion in their cores. Let us begin with the most common type of star in the galaxy, because it is not the type of star you might expect. When you look up at the night sky with your naked eye, most of the stars you see are bright, relatively massive stars, stars like the Sun or larger. They are visible because they are bright enough to be seen across great distances, but they are not the most common stars. The most common stars in the Milky Way, by a very large margin, are called red dwarf stars. Red dwarfs are small, cool, dim stars, much smaller and cooler and dimmer than the Sun. They range in mass from about 1/10 the mass of the Sun, up to about half the mass of the Sun. They burn their fuel very slowly, so slowly that a red dwarf can live for trillions of years, far longer than the current age of the universe. Not a single red dwarf in the entire galaxy has yet reached the end of its life. They are all still in their infancy, still burning quietly, still glowing their faint, steady red. Because red dwarfs are so dim, you cannot see any of them with your naked eye, even though they are the most numerous stars in the galaxy. The nearest star to the Sun, Proxima Centauri, is a red dwarf. It is only about 4¼ light-years away, a cosmic stone's throw, and yet it is too dim to see without a telescope. If you could somehow gather up all the stars in the galaxy and count them by type, perhaps 3 out of every 4 would be red dwarfs. They are the quiet majority, the small, patient stars that fill the galaxy's disk and halo, burning their fuel so slowly that they will still be shining long after the Sun and all the other bright stars have faded away. At the other end of the scale are the massive stars, the ones that are much larger and hotter and brighter than the Sun. These stars are rare, but they dominate our view of the night sky because they are so luminous. A star that is 10 times the mass of the Sun can be thousands of times brighter. A star that is 50 times the mass of the Sun can be hundreds of thousands of times brighter. These massive stars burn their fuel at a furious rate, living fast and dying young. While the Sun will live for about 10 billion years in total, a star 50 times the Sun's mass might live for only a few million years before it exhausts its fuel and ends its life in a supernova explosion. These massive stars are the ones that light up the spiral arms, illuminating the gas clouds around them, creating the glowing nebulae that trace out the spiral structure. They are born in the dense gas of the arms. They live their short, brilliant lives there, and they die there, seeding the surrounding space with the heavier elements they forged in their cores. The Sun sits in the middle of this range. It is an average star, an unremarkable star by galactic standards. It is not especially large, not especially small. It is not especially hot, not especially cool. It is a yellow dwarf, a star of moderate mass and moderate temperature, burning its fuel at a moderate rate. There are many stars like the Sun in the galaxy, though they are outnumbered by the red dwarfs. The Sun is ordinary, typical, a middle-of-the-road star in a galaxy full of stars of all kinds, and that ordinariness is something to rest in. The Sun is not special. It is just one of 100 billion or more, doing what stars do, shining steadily for billions of years, providing warmth and light to its planets. There is a quiet comfort in that ordinariness, a sense of belonging. The Sun is not an outlier. It is part of the great family of stars, a typical member, a familiar face in the crowd. Stars are not scattered evenly through the galaxy. They are gathered more densely in some places than in others. The disk and the bulge are where most of the stars live. In the disk, stars are arranged in the thin, flat plane, with the spiral arms being regions of slightly higher density. Between the arms, the density of stars is lower, but still far higher than in the halo above and below the disk. In the bulge, stars are packed much more closely together, their average separation being much smaller than in our part of the disk. If you lived on a planet in the bulge, the night sky would be ablaze with stars, many of them as bright as the full moon, and the sky would never be truly dark. In the halo, by contrast, the stars are thinly scattered, with vast distances between them. A planet in the halo would have a night sky dominated by the glow of the Milky Way's disk far below, with only a few nearby stars visible. Stars are also grouped into clusters, bound collections of stars that form together or are held together by their mutual gravity. There are two main types of star clusters in the Milky Way, and they are different enough to be worth describing gently. The first type is called an open cluster. An open cluster is a loose group of stars, usually a few dozen to a few thousand, that formed from the same cloud of gas and dust. They are born together, and they drift through the galaxy together for a while. But over time, gravitational interactions with other stars and gas clouds pull them apart. Open clusters are relatively young, often found in the disk and especially in the spiral arms, where star formation is active. The Pleiades, a famous cluster visible to the naked eye in the constellation Taurus, is an open cluster. It is a group of young, hot blue stars, still nestled in the faint wisps of gas from which they formed. When you look at the Pleiades, you are looking at a stellar nursery, a family of stars that have only recently begun their lives. The second type of star cluster is called a globular cluster. Globular clusters are very different from open clusters. They are much larger, containing hundreds of thousands or even millions of stars, packed into a roughly spherical shape. They are very old, among the oldest objects in the galaxy, formed in the early days of the Milky Way, 10 to 13 billion years ago. They orbit the galaxy in the halo, in large, tilted, elliptical orbits that take them high above and far below the disk. The stars in a globular cluster are densely packed, so densely that if you lived on a planet inside one, the night sky would be a carpet of stars, with tens of thousands of stars, brighter than anything we see in our own night sky. The Milky Way has about 150 to 200 known globular clusters, and they are among the most beautiful objects to observe through a telescope, appearing as tight, glittering balls of starlight. The stars in these clusters, and the stars scattered through the disk and bulge and halo, are not all the same age. The galaxy contains a mix of stellar generations. The oldest stars are found in the bulge and the halo and the globular clusters, stars that formed when the galaxy was young, when the universe itself was young. These old stars tend to be lower in what astronomers call metals, which in astronomy means any element heavier than hydrogen and helium. The early universe was almost entirely hydrogen and helium, with only a tiny trace of lithium. Heavier elements, like carbon, oxygen, iron, and so on, were forged later, inside stars, and scattered into space when those stars died. So the oldest stars are metal-poor, made of nearly pristine material from the Big Bang. Younger stars, like the Sun, formed later, from gas that had been enriched by many generations of star birth and star death. The Sun has a higher metal content than the oldest stars, which is why it has planets around it. Rocky planets like Earth, made of elements that were not present in the early universe. We will talk more about this process of enrichment later, when we sit with star birth and star death. For now, it is enough to know that the galaxy is a mix of old and young, of metal poor and metal rich, of stars that remember the early universe and stars that are brand new. The colors of stars are a direct reflection of their surface temperatures, and you can see these colors with your own eyes if you look carefully at the night sky. The hottest stars glow blue or blue-white. The coolest stars glow red or orange. In between, you have white stars, yellow-white stars like the Sun, and yellow-orange stars. The color is a simple consequence of physics, the same physics that makes a hot flame burn blue and a cooler flame burn orange. The bright star Rigel in Orion is blue-white, a hot, massive star. Betelgeuse, also in Orion, is red, a cool, bloated supergiant star nearing the end of its life. The Sun is yellow-white, a middle-temperature star, steady and calm. These colors are real, not an illusion, and they are one of the ways astronomers can measure the temperatures of stars without ever visiting them. The distances between stars are vast, even in the relatively dense disk. The nearest star to the Sun, Proxima Centauri, is about 4¼ light-years away. That is a distance so large that light, the fastest thing in the universe, takes more than 4 years to cross it. If you shrank the Sun to the size of a grapefruit, the Earth would be a tiny speck, orbiting about 15 meters away. On that same scale, Proxima Centauri would be another grapefruit about 4,000 kilometers away, roughly the distance from New York to Los Angeles, and that is the nearest star. Most stars in the galaxy are separated by similar or greater distances. The galaxy is mostly empty space, with stars like tiny islands of light in a vast, dark ocean. Collisions between stars are incredibly rare. When galaxies merge, the stars pass right by each other, their mutual distances so great that the chances of a direct collision are vanishingly small. The gas and dust clouds collide, triggering bursts of star formation, but the stars themselves sail through like ships passing in the night. So the galaxy is filled with stars, 100 billion or more, of every size and color and age, scattered across the disk and the bulge and the halo, grouped into clusters, drifting through the arms, burning their fuel at their own steady pace. And you are sitting on a planet orbiting one of those stars, an average star, an unremarkable star, a star that is just one among billions. That thought can feel lonely if you let it, but it can also feel peaceful, a sense of belonging to something vast and varied and beautiful. You are part of a galaxy that is full of light, full of suns, full of other worlds that we can only imagine. The stars you see at night are your neighbors, some of them like the sun, some of them very different, all of them part of the same great family. And the spaces between them, the dark spaces, are not truly empty, as we will see next. They are filled with a thin, quiet medium of gas and dust, the raw material from which new stars are born, the breath of the galaxy itself. But for now, just rest with the stars, with their variety and their numbers, with the quiet knowledge that you are surrounded by 100 billion suns, each one a world unto itself, each one a slow-burning candle in the vast, dark night of the galaxy. The night is full of stars, and you are resting among them, held by the same gravity that holds them, part of the same great structure, part of the same quiet, ancient light. The night is full of stars, and you are resting among them, held by the same gravity that holds them, part of the same quiet, ancient light. But the stars are not the whole story of the galaxy. Between the stars, in the vast, dark spaces that separate one sun from another, there is material. Not a lot of material, not by everyday standards. The space between stars is emptier than any vacuum we can create on Earth. But it is not truly empty. It contains a thin, diffuse medium of gas and dust, scattered across the light years, filling the disk and the arms of the galaxy like a faint, invisible breath. This material has a name. It is called the interstellar medium. The word interstellar simply means between the stars, and the medium is the stuff that fills that space. The interstellar medium is mostly gas, and the gas is mostly hydrogen, the simplest and lightest element in the universe. A hydrogen atom consists of a single proton and a single electron, a tiny, simple building block. Most of the gas between the stars is hydrogen, along with a smaller amount of helium, the second lightest element. Together, hydrogen and helium make up about 98% of the normal matter in the interstellar medium. The remaining 2% is a mix of heavier elements, the elements that astronomers call metals: carbon, oxygen, nitrogen, neon, iron, and many others. These heavier elements are present only in trace amounts, but they are important. They are the raw material for planets, for life, for the solid ground beneath your feet. They were forged inside earlier generations of stars, as we will talk about later, and they were scattered into space when those stars died. Now they drift between the stars, mixed with the hydrogen and helium, waiting to be gathered up into new stars and new worlds. In addition to the gas, there is dust. Interstellar dust is not like the dust you find under your bed. It is made of tiny solid particles, mostly silicates and carbon compounds, each particle only a fraction of a micron across, smaller than the wavelength of visible light. These dust grains are rare, making up only about 1% of the mass of the interstellar medium, but they have an effect far out of proportion to their mass. Dust grains scatter and absorb visible light, blocking it from passing through. This is why we cannot see the center of the galaxy with visible light. The dust between here and the center is not thick like a wall, but over 26,000 light-years. The cumulative effect is enough to dim the light by a factor of many billions. The light from the central bulge, which would otherwise blaze in our night sky, is reduced to a faint glow, its visible light almost entirely blocked by the thin haze of dust. But dust is not just an obstacle. It is also a helper. Dust grains provide surfaces on which atoms can meet and combine to form molecules. In the cold, dense clouds of the interstellar medium, atoms stick to the surfaces of dust grains, finding each other and reacting to form more complex molecules. Water, carbon monoxide, ammonia, formaldehyde, and even simple organic molecules like methanol and ethanol have been detected in interstellar clouds. These molecules are the first steps on the long, slow path toward the chemistry of life. They form in the quiet darkness between the stars, on the surfaces of tiny dust grains, and they wait there, preserved in the cold, until the cloud they inhabit begins to collapse and form new stars and new planets. The interstellar medium is not uniform. It varies enormously in density and temperature. Most of the volume of the interstellar medium is filled with a very hot, very thin gas, heated by the shock waves from supernova explosions and the intense radiation from massive stars. This hot gas can reach temperatures of millions of degrees, but it is so thin, so diffuse, that it would feel like a perfect vacuum to us. Within this hot, thin gas, there are cooler, denser regions, clouds of hydrogen that are still mostly atomic, with temperatures of a few thousand degrees. And within these cooler clouds, there are even colder, denser cores, regions where the hydrogen has combined into molecules, where the temperature drops to just a few degrees above absolute zero. These dense, cold cores are the places where stars are born. They are the stellar nurseries, the quiet cradles of the galaxy. When one of these dense clouds becomes large and massive enough, it can begin to collapse under its own gravity. The collapse is slow at first, a gentle inward drift of gas and dust. But over time, the cloud fragments into smaller clumps, and each clump continues to collapse, heating up as it does so. The center of each collapsing clump becomes denser and hotter, until eventually the temperature and pressure are high enough for nuclear fusion to begin. A new star switches on, its core igniting in a burst of energy, and the surrounding gas and dust are blown away or gathered into a rotating disk from which planets can form. This is the process of starbirth, and it happens inside the densest parts of the interstellar medium, inside the cold, dark clouds that are often called nebulae. The word nebula, in its simplest sense, means a cloud. In astronomy, it refers to any cloud of gas and dust in space. Some nebulae are dark, so dense with dust that they block the light of stars behind them, appearing as black patches against the brighter background of the Milky Way. Others are bright, lit up by the light of nearby stars. Some glow with a reddish light, the characteristic color of hydrogen gas that has been heated and ionized by the ultraviolet radiation from hot, young stars. These are called emission nebulae. Others glow with a bluish light, the result of starlight being scattered by dust grains, in the same way that the Earth's sky is blue because sunlight is scattered by air molecules. These are called reflection nebulae. And still others are the remnants of dead or dying stars, the expanding shells of gas ejected in the final stages of a star's life. These are called planetary nebulae, or supernova remnants, and they represent the end of the stellar life cycle, which we will talk about in the next section. One of the most well-documented stellar nurseries in the Milky Way is the Orion Nebula, a bright, glowing cloud in the constellation Orion, visible from Earth with the naked eye as a faint smudge in the sword of the hunter. The Orion Nebula is part of our own spiral arm, the Orion Arm, and it is one of the nearest regions of active star formation to the Sun, at a distance of about 1,300 light-years. Inside the Orion Nebula, hundreds of new stars are forming right now, some of them only a few million years old, mere infants by stellar standards. The brightest of these young stars, a tight cluster called the trapezium, lights up the surrounding gas, causing it to glow with a soft pinkish light. The nebula is a place of quiet, ongoing creation, a place where the raw material of the galaxy is being transformed into new suns, new solar systems, new possibilities for life. And you can see it with your own eyes, on a clear winter night, a faint, misty patch of light in the sky, a window into the birth process of stars. The Orion Nebula is just one of many such nurseries in the Milky Way. Others are larger, like the Carina Nebula in the southern sky, or the Eagle Nebula, famous for the Hubble Space Telescope image called the Pillars of Creation, which shows towering columns of gas and dust being sculpted by the radiation and winds from nearby massive stars. These pillars are dense regions of the cloud that have resisted being blown away, and inside them, new stars are forming, hidden from view by the dust that shrouds them. The dust in these clouds is so thick that visible light cannot penetrate it, which is why astronomers use infrared and radio telescopes to peer inside and study the earliest stages of star formation. The dust in the interstellar medium has another effect, one that is worth sitting with for a moment. Because dust scatters and absorbs visible light, it changes the way we see the galaxy. If there were no dust between the stars, the night sky would be much brighter. The central bulge of the Milky Way would shine as bright as the full moon, and the band of the Milky Way would be more vivid and detailed. But the dust dims and reddens the light, blocking some of it entirely and shifting the colors of what gets through toward the red end of the spectrum. This is the same effect that makes sunsets red on Earth. The blue light is scattered away by the atmosphere, leaving the red light to pass through. In the galaxy, the dust does the same thing, scattering blue light and letting red light pass, so that distant stars and galaxies appear redder than they truly are. Astronomers have to correct for this reddening when they measure the properties of stars and other objects, a careful, patient process of accounting for the dust that lies between us and what we are looking at. The interstellar medium is also the medium through which shock waves travel. When a massive star explodes as a supernova, it sends out a blast wave that sweeps through the surrounding gas, compressing it, heating it, and sometimes triggering the collapse of nearby clouds to form new stars. These shock waves are one of the mechanisms that help to sustain the spiral structure of the galaxy. As the shock waves move through the disk, they compress the gas in the spiral arms, triggering waves of star formation that light up the arms with bright, young stars. In this way, the death of one star can lead to the birth of many others, a slow, cyclical process that has been going on for billions of years. The material between the stars is quiet and thin and patient. It drifts through the galaxy in slow, gentle currents, stirred by the motion of stars and the explosions of supernovae. It collects into clouds, and those clouds collapse into stars, and those stars eventually return their material to the interstellar medium, enriched with heavier elements forged in their cores. It is a cycle, a slow breathing in and out, a rhythm that has been repeating since the galaxy was young. The interstellar medium is the breath of the galaxy, the raw material of creation, the quiet, invisible substance that fills the spaces between the stars. And you are breathing it, in a sense, because the atoms in your body, the carbon and oxygen and nitrogen and iron, were once part of that interstellar medium. They drifted between the stars for billions of years before being gathered into the cloud that formed the sun and the earth. You are made of interstellar gas and dust, gathered up and shaped into a living being, resting now in the dark, part of the same cycle that continues all around you. So the next time you look up at the night sky, or even just picture it behind your closed eyes, remember the spaces between the stars. They are not empty. They are filled with the quiet potential of creation, with the thin, gentle breath of the galaxy, waiting to become new suns, new worlds, new life. The stars are beautiful, but the spaces between them are beautiful too. A quiet, patient medium that holds the seeds of everything that is yet to come. And now, as you drift deeper into the stillness, you can let that quiet medium carry you, the thin, invisible substance of the galaxy, the raw material of stars, the breath that has been breathing for 13 billion years, and will keep breathing long after this night has faded into a peaceful, dreamless sleep. The quiet medium of gas and dust drifts through the galaxy, patient and unseen, holding the seeds of everything that is yet to come. And now we can follow those seeds as they gather and collapse and ignite, and we can follow the stars they become through their long, slow lives, and we can sit with the quiet, natural end that awaits every star. This is the rhythm of star birth and star death, a rhythm that has been repeating since the galaxy was young, a rhythm as natural and unhurried as breathing. Stars form when gravity slowly pulls together clouds of gas and dust. This is the simple, plain beginning. Somewhere in the disk of the galaxy, in a dense, cold region of the interstellar medium, a cloud of gas and dust begins to feel its own weight. The cloud is mostly hydrogen, with some helium and a trace of heavier elements, and it is spread out across light years of space. But over time, the quiet, patient pull of gravity draws the material inward. The cloud begins to shrink, slowly at first, then faster as the density increases. As the cloud shrinks, it heats up. The gas particles collide more frequently, and those collisions convert gravitational energy into heat. The center of the cloud becomes warmer and denser than the outer regions. A dense core forms, a knot of gas that will become a star. The process is slow by human standards. It can take millions of years for a cloud to collapse into a star. But on the scale of the galaxy, it is a steady, ongoing process, happening right now in nebulae across the Milky Way. The Orion Nebula, which we talked about earlier, is one of those places. The Eagle Nebula is another. The Carina Nebula is another. In each of these stellar nurseries, gravity is quietly at work, pulling gas and dust together, building new suns. As the core of the collapsing cloud grows denser and hotter, it eventually reaches a point where the conditions are right for something new to happen. The temperature at the center climbs to millions of degrees. The pressure becomes enormous, and at that point, a process called nuclear fusion begins. Fusion is the heart of a star. It is what makes a star, rather than just a ball of gas. In plain terms, fusion is the joining together of smaller atomic nuclei to form larger ones, a process that releases a great deal of energy in the form of light and heat. In the core of a star like the Sun, hydrogen nuclei, which are single protons, are fused together in a series of steps to form helium nuclei. Each time 4 hydrogen nuclei combine to make one helium nucleus, a small amount of mass is converted into energy. That energy, multiplied by the enormous number of fusion reactions happening every second, is what makes the Sun shine. It is what makes all stars shine. The energy from fusion creates an outward pressure that balances the inward pull of gravity. The star settles into a long, stable period of its life, burning hydrogen into helium in its core, shining steadily for millions or billions of years. This stable period is where the Sun is now. The Sun has been burning hydrogen into helium for about 4.5 billion years, and it has enough fuel to continue for about another 5 billion years. For all of human history, and for all of the history of life on Earth, the Sun has been in this steady, middle phase of its life, a reliable, stable source of warmth and light. It is not growing hotter or colder in any way we can feel. It is simply burning, quietly, steadily, turning hydrogen into helium, radiating energy into space, holding its planets in their orbits. But a star cannot burn forever. Eventually, the hydrogen in the core runs out. What happens next depends on the mass of the star. Different stars end their lives in different ways, and the manner of a star's death is determined by the mass it was born with. This is one of the quiet, settled facts of astronomy. a fact that has been verified by decades of observation and modeling. The fate of a star is written in its mass. For smaller stars, stars like the Sun or lighter, the end is gentle. When the hydrogen in the core is exhausted, the core begins to contract under gravity. The contraction heats the core further, and the outer layers of the star expand and cool. The star becomes a red giant, a large, cool, reddish star that can swell to many times its original size. When the Sun becomes a red giant, billions of years from now, it will expand to engulf the orbits of Mercury and Venus, and perhaps the Earth as well. The outer layers will be cast off into space, forming a beautiful, glowing shell of gas called a planetary nebula. The name is a historical accident. Planetary nebulae have nothing to do with planets. They are the gently shed outer layers of dying stars, lit up by the hot, exposed core that remains. That core is called a white dwarf. A white dwarf is a small, dense ball of carbon and oxygen, about the size of the Earth but with the mass of a star. It is supported not by fusion, which has stopped, but by a quantum mechanical effect called electron degeneracy pressure. The white dwarf will slowly cool over billions of years, fading from white to yellow to orange to red to brown, and eventually, after a span of time longer than the current age of the universe, to a cold, dark, theoretical black dwarf. The death of a sun-like star is a quiet fading, a slow dimming, a gentle return of material to the interstellar medium. For much larger stars, stars more than about 8 times the mass of the Sun, the end is different. More massive stars burn their fuel much faster. After the hydrogen in the core is exhausted, the core contracts and heats up enough to begin fusing helium into carbon, and then carbon into neon, and then neon into oxygen, and then oxygen into silicon, and finally silicon into iron. Each stage of fusion goes faster than the last. The star develops a layered structure, like an onion, with different elements fusing in different shells around the core. But iron is the end of the line. Fusing iron does not release energy, it consumes it. Once the core becomes iron, fusion can no longer support the star against gravity. The core collapses, suddenly and catastrophically, in a matter of seconds. The collapse releases an enormous amount of energy, and the outer layers of the star are blasted into space in a titanic explosion called a supernova. A supernova is, in plain terms, a star exploding. It is one of the most energetic events in the universe, briefly outshining an entire galaxy of stars. But for our purposes tonight, the most important thing about a supernova is not the explosion itself. It is what the explosion creates and scatters. In the intense heat and pressure of a supernova, and during the final stages of the star's life leading up to it, heavier elements are forged. Elements like oxygen, calcium, magnesium, silicon, and iron, elements that are essential for planets and for life, are created in the cores of massive stars and in the explosions that end them. The supernova scatters these elements into the surrounding interstellar medium, enriching the gas and dust with the raw materials for new stars, new planets, new life. This process, the creation of heavier elements inside stars, is called nucleosynthesis. The word simply means the making of atomic nuclei, and it is a settled, verified fact of science that most of the elements in the universe, heavier than hydrogen and helium, were made inside stars. The hydrogen and helium themselves were made in the first few minutes after the Big Bang. But the carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood, the silicon in the rocks beneath your feet, all of these were forged inside earlier generations of stars, stars that lived and died long before the Sun and Earth were born. When those stars exploded as supernovae, they scattered their newly made elements into space. Those elements, mixed with the interstellar medium, drifted through the galaxy for millions or billions of years, and eventually became part of the cloud of gas and dust that collapsed to form our solar system. The Earth, and everything on it, including you, is made of stardust. That is not poetry. It is a literal, settled, verified fact. Let that fact sit quietly with you for a moment. The atoms in your body, The ones that make up your skin and bones and breath are ancient. They were forged in the cores of stars that died billions of years ago, on the other side of the galaxy. They traveled across the light years, drifting through the interstellar medium, part of the quiet breath of the galaxy. They were gathered into the cloud that formed the sun and the planets. They became part of the Earth. They were taken up by the first living cells, passed down through billions of generations of life, and eventually they came together to form you, here and now, lying in the dark, listening to these words. You are not separate from the galaxy. You are made of it. The galaxy is not somewhere else. It is inside you, quite literally, in every atom of your being. After a supernova, what remains of the star's core depends on its mass. For the most massive stars, the core collapses into a neutron star, an incredibly dense ball of neutrons only a few kilometers across, supported by neutron degeneracy pressure. A neutron star is so dense that a teaspoon of its material would weigh billions of tons. Some neutron stars spin rapidly and emit beams of radiation, and these are called pulsars. For the very most massive stars, the core collapses further, past the point where neutron degeneracy pressure can hold it up, and it becomes a black hole, a region of space where gravity is so strong that nothing can escape, as we talked about earlier with Sagittarius A star. But Sagittarius A star is a supermassive black hole, millions of times the mass of the Sun, and it did not form from a single star. It formed from the accumulation of mass over billions of years, perhaps from the merger of smaller black holes and the infall of gas and stars. The black holes that form from single massive stars are smaller, typically a few to a few dozen times the mass of the Sun, and they are scattered throughout the galaxy, quiet, dark remnants of stars that burned bright and died young. So the cycle of star birth and star death is a true cycle, a recycling of material through the galaxy. Stars form from the interstellar medium. They burn hydrogen and helium into heavier elements. When they die, they return that enriched material to the interstellar medium, either gently, as planetary nebulae, or violently, as supernovae. New stars form from that enriched material, and the cycle continues. Each generation of stars is born with a slightly higher proportion of heavy elements than the one before. The first stars in the galaxy, the ones that formed shortly after the Milky Way came together, were made of almost pure hydrogen and helium, with almost no heavier elements at all. They were massive, bright, and short-lived, and they seeded the galaxy with the first heavy elements. The next generation of stars had a little more carbon, a little more oxygen, a little more iron, and so on, generation after generation, until the Sun formed, with its mix of about 2% heavy elements, enough to build rocky planets and, eventually, life. This rhythm, this slow breathing of birth and death and rebirth, is one of the most fundamental processes in the galaxy. It is not dramatic in the way that human events are dramatic. It unfolds over millions and billions of years, far too slowly for any single life to witness more than a tiny slice of it. But it is real, and it is steady, and it has been going on for 13 billion years. The Orion Nebula, glowing faintly in the winter sky, is part of this rhythm. The Pleiades, the young star cluster, is part of it. The white dwarfs and neutron stars and black holes scattered invisibly through the galaxy are part of it. And you are part of it, made of the same elements, born from the same cycle, a child of the stars in the most literal sense. As you lie here in the dark, you can let that knowledge settle over you like a soft blanket. You are not a stranger to the galaxy. You are a product of it, a piece of it that has become conscious and aware, able to look up at the night sky and wonder about its origins. The iron in your blood was forged in a supernova. The calcium in your bones was forged in the heart of a star. The oxygen you breathe was made in the final stages of a massive star's life. Every atom of your body, except for the hydrogen, which is primordial, has been through the furnace of a star. You have been part of this galaxy for billions of years, and you will be part of it for billions more, as your atoms eventually return to the interstellar medium and are gathered up into new stars, new planets, new life. The cycle continues, slow and patient and beautiful, and you are part of it, resting now in the quiet heart of the Milky Way, cradled by the same gravity that shapes the stars. The cycle continues, slow and patient and beautiful, and you are part of it, resting now in the quiet heart of the Milky Way, cradled by the same gravity that shapes the stars. But the Milky Way is not the only galaxy in the universe. It is not even the only galaxy in our immediate cosmic neighborhood. The Milky Way has neighbors, companions, smaller and larger galaxies that share this region of space with us, bound together by the quiet, patient pull of gravity. And now we can widen our view, gently and without hurry, to take in these neighbors, these other islands of stars that drift alongside our own. The Milky Way is not alone. It has smaller companion galaxies bound to it by gravity, galaxies that orbit it in the same way that the Moon orbits the Earth, or the Earth orbits the Sun. These smaller companions are called satellite galaxies. The word satellite means a body that orbits a larger body, and these satellite galaxies are true satellites of the Milky Way, held in its gravitational embrace, circling it slowly over hundreds of millions or billions of years. They are distinct, separate galaxies in their own right, each with their own stars and gas and dust and dark matter. But they are much smaller than the Milky Way, and they are gravitationally bound to it, part of the extended family of our home galaxy. The two most well-documented satellite galaxies of the Milky Way are the Large Magellanic Cloud and the Small Magellanic Cloud. Their names come from the explorer Ferdinand Magellan, whose expedition in the early 1500s recorded their presence in the southern sky, though of course they were known to people in the southern hemisphere long before that. The Magellanic Clouds are visible to the naked eye, but only from the southern hemisphere or from latitudes near the equator. They appear as two faint, misty patches of light, detached from the band of the Milky Way, looking almost like small, detached pieces of the Milky Way that have drifted away. But they are not pieces of our galaxy. They are separate galaxies orbiting the Milky Way at distances of about 160,000 light-years for the Large Magellanic Cloud and about 200,000 light-years for the Small Magellanic Cloud. Let those distances settle for a moment. 160,000 light-years. That is larger than the diameter of the Milky Way's disk. The Large Magellanic Cloud is outside the main body of our galaxy, sailing through the halo, bound to us by gravity but distinct and separate. It is a small galaxy, classified as an irregular galaxy rather than a spiral, because it does not have the neat, organized structure of a spiral like the Milky Way. It is more of a ragged, asymmetrical collection of stars and gas, shaped by its gravitational interactions with the Milky Way and with its smaller sibling, the Small Magellanic Cloud. The Small Magellanic Cloud is even more irregular, a wispy, disrupted galaxy that has been stretched and pulled by tidal forces. Magellanic Clouds are sites of active star formation, rich in gas and dust, with bright nebulae and young star clusters. One of the most famous star-forming regions in the local group is the Tarantula Nebula, located in the Large Magellanic Cloud. It is an enormous stellar nursery, so bright that if it were as close to Earth as the Orion Nebula, it would cast visible shadows at night. The Magellanic Clouds are also connected to the Milky Way by a stream of gas called the Magellanic Stream, a trail of hydrogen that has been pulled out of the clouds by gravitational interactions with our galaxy. This stream arcs across a large portion of the southern sky, invisible to the eye but detectable by radio telescopes, a faint, tenuous bridge between the galaxies. There are other satellite galaxies of the Milky Way, though they are smaller and fainter than the Magellanic Clouds. Astronomers have discovered dozens of small, dim dwarf galaxies orbiting the Milky Way, some of them so faint that they were only detected in the last few decades, using sensitive digital cameras and large telescopes. These dwarf galaxies have names like the Sagittarius dwarf spheroidal galaxy, the Fornax dwarf, the Sculptor dwarf, and many others. They are mostly found in the halo of the Milky Way, far above and below the disk, and they are very old, made mostly of ancient stars with very little gas or ongoing star formation. They are the faint, quiet remnants of the early universe, small galaxies that have been orbiting the Milky Way for billions of years, slowly being stripped of their stars and gas by the larger galaxy's gravity. And then there is the nearest large spiral galaxy to the Milky Way, the Andromeda Galaxy. Andromeda is not a satellite of the Milky Way. It is a comparable spiral galaxy, slightly larger than our own, with an estimated 1 trillion stars compared to the Milky Way's 100 to 400 billion. It lies at a distance of roughly 2.5 million light-years from us, a distance so large that the light from Andromeda that reaches our telescopes tonight began its journey 2.5 million years ago, when our ancestors were just beginning to use stone tools on the plains of Africa. Andromeda is visible to the naked eye from the northern hemisphere on a clear, dark night, appearing as a faint, elongated smudge of light in the constellation of Andromeda. It is the most distant object the human eye can see without help, and for most of human history, no one knew what it was. It was simply a faint, fuzzy patch in the sky, catalogued by early astronomers as a nebula. It was only in the early 20th century that astronomers measured its distance and realized it was a separate galaxy, an island universe of its own, far outside the boundaries of the Milky Way. Andromeda is a beautiful spiral galaxy, tilted at an angle to our line of sight so that we see it partially edge-on. Through a telescope, it is a stunning sight, a great wheel of stars with a bright central bulge and dark dust lanes tracing out its spiral arms. It has its own satellite galaxies, including two prominent ones called Messier 32 and Messier 110, which are small elliptical galaxies orbiting Andromeda. Andromeda is, in many ways, a sibling of the Milky Way, a similar spiral galaxy with a similar history and a similar structure, drifting through space about 2.5 million light-years away. And here is something slow and patient to sit with. The Milky Way and Andromeda are moving toward each other. They are being pulled together by their mutual gravity, falling toward one another across the vast emptiness between galaxies. Their relative speed is estimated at about 110 kilometers per second. That sounds fast to our earthbound ears, but when measured against the distance that separates them, it is very, very slow. At that speed, it will take about 4 billion years for the two galaxies to come together and begin to merge. 4 billion years. That is a span of time almost as long as the entire history of the Earth. It is so far in the future that it does not belong to any sense of human urgency. It is a slow, patient approach, a gravitational dance that will unfold over timescales far longer than any single life or lifetime. When the Milky Way and Andromeda do eventually merge, it will not be a collision of stars. As we talked about earlier, the distances between stars are so vast that even when two galaxies pass through each other, individual stars almost never collide. Instead, the gas and dust clouds in the two galaxies will crash together, triggering an enormous burst of star formation. The spiral structures of both galaxies will be disrupted, and over hundreds of millions of years, they will settle into a new, larger galaxy, an elliptical galaxy that some astronomers have already given a name, Milkomeda or Milkdromeda. The Sun, if it still exists at that point, will likely end up on a different orbit, perhaps farther out from the center of the new galaxy, perhaps closer in. The Earth, if it still exists, will see a night sky transformed, with the bright core of the new galaxy dominating the view, and the band of the Milky Way replaced by a more diffuse, elliptical glow. But all of that is far, far in the future. There is no urgency in it. It is a process that will unfold on timescales of billions of years, a slow, natural merging of two great galaxies, governed by the same quiet gravity that holds everything together. The universe is full of such mergers. We can see them happening in other parts of the sky, pairs of galaxies caught in the act of merging, their shapes distorted, their stars flung out in long tidal tails, their gas set ablaze with new star formation. It is a normal part of the life of galaxies, a slow dance of attraction and combination that has been happening since the earliest days of the universe. The Milky Way, Andromeda, the Magellanic Clouds, and all the other smaller galaxies in our immediate vicinity are part of a larger, loosely bound collection of galaxies called the local group. The local group is our galactic neighborhood, a small cluster of galaxies bound together by gravity, drifting through space as a unit. It contains more than 50 known galaxies, most of them small dwarf galaxies, with the Milky Way and Andromeda as the two largest members. There is also a third spiral galaxy in the local group, called the Triangulum Galaxy, or Messier 33, which is smaller than the Milky Way and Andromeda, and lies a bit farther from us than Andromeda. The Triangulum Galaxy is also visible with the naked eye under very dark skies, though it is fainter and more diffuse than Andromeda. The local group is not the largest cluster of galaxies by any means. It is a small, modest group compared to the great clusters like the Virgo cluster, which contains thousands of galaxies and lies about 50 million light-years away. The local group is gravitationally bound to the Virgo cluster and is part of an even larger structure called the Virgo supercluster, which in turn is part of an even larger structure called Laniakea, a vast supercluster of galaxies that stretches across hundreds of millions of light-years. But these are scales that we do not need to explore tonight. Tonight, the local group is enough. The Milky Way and its immediate neighbors, bound together by gravity, drifting through space as a small, quiet family of galaxies. There is a peace in knowing that we are not alone, that the Milky Way is not solitary in the vastness of space. It has companions, neighbors, fellow travelers on the long, slow journey through cosmic time. The Magellanic Clouds are right there, just outside the Milky Way's disk, visible to the naked eye from the southern half of the Earth. Andromeda is right there, a faint smudge in the northern sky, the light of 1 trillion stars that has traveled 2.5 million years to reach your eyes. The dwarf galaxies are out there too faint to see without telescopes, but present, orbiting in the halo, remnants of the early universe. All of these galaxies are part of the same gravitational family, bound to each other, moving through space together. And you are here, on a planet orbiting a star in the Orion Arm of the Milky Way, looking out at these neighbors from the inside. The night sky is not just the stars of our own galaxy. It also contains the faint light of other galaxies, other islands of stars, other worlds beyond counting. When you look at the faint smudge of Andromeda, you are seeing the combined light of 1 trillion suns, 1 trillion solar systems, 1 trillion possible worlds. And that light has been traveling through the emptiness between galaxies for 2.5 million years to reach you, here, tonight, as you lie with your eyes closed, listening to these words. The local group is quiet and stable. The galaxies within it move slowly, bound by gravity, their paths determined by the same laws of physics that govern the orbit of the moon around the Earth. There is no rush in their motion, no urgency in their approach. Andromeda and the Milky Way will merge, eventually, but that event is so far in the future that it belongs to a different era of the universe, a time when the sun will have already grown old and faded. For now, the two galaxies are simply neighbors, drifting together, their mutual gravity a gentle, invisible thread connecting them across the void. So as you drift deeper into the stillness, you can hold in your mind the image of the Milky Way, not as a solitary island, but as part of a small group of galaxies, a quiet neighborhood in a quiet corner of the universe. The Magellanic Clouds are nearby, small and irregular, glowing with new star formation. Andromeda is farther, a great spiral like our own, visible as a faint smudge on a dark night. The dwarf galaxies are scattered through the halo, faint and ancient. All of them are bound together, part of the local group, part of the larger structure of the cosmos. And you are part of it too, a tiny, conscious piece of the Milky Way, looking out at its neighbors, resting in the quiet knowledge that the universe is full of other galaxies, other stars, other worlds, all of them moving in their own slow, patient rhythms, all of them part of the same great, quiet night. The universe is full of other galaxies, other stars, other worlds, all of them moving in their own slow, patient rhythms, all of them part of the same great, quiet night. And now, as we drift closer to the end of our journey together, we can stretch time out fully, letting it expand in all directions, backward into the deep past, and forward into the slow, distant future. This is the scale of deep time, a scale so vast that it can feel like a release, a letting go of all urgency, all deadlines, all the small, pressing concerns of the day. In deep time, there is no hurry. There is only the slow unfolding of processes that began long before us and will continue long after. The Milky Way is estimated to be roughly 13 billion years old. That number, 13 billion years, is one of the quiet, settled facts of modern astronomy, measured through a variety of independent methods that all converge on roughly the same answer. The oldest stars in the galaxy, found in globular clusters and in the halo, have ages estimated at around 13 billion years. The white dwarfs in the disk, the slowly cooling remnants of ancient stars, also point to a similar age. And the larger cosmological picture, the measured age of the universe itself at about 13.8 billion years, sets an upper limit. The Milky Way formed relatively soon after the Big Bang, within the first billion years of the universe's existence. It is among the oldest structures in the cosmos, a galaxy that has been around for most of cosmic history. 13 billion years is a span of time that the human mind cannot fully grasp, and that is perfectly fine. We are not meant to grasp it fully. We are meant to rest in it, to let it wash over us like a slow, deep ocean. To put it in a gentle context, the entire history of the Earth, from its formation to the present night, is about 4.5 billion years. The Milky Way is roughly 3 times older than the Earth. The galaxy was already ancient, already spinning quietly in the void, when the cloud of gas and dust that would become our solar system began to collapse. The Sun and the Earth formed much later, from that same slowly collapsing cloud, about 4.5 billion years ago. The galaxy had already existed for more than 8 billion years before the Earth even appeared. Stars had been born and died, generations of them, seeding the galaxy with the heavy elements that would eventually form our planet and our bodies. The Milky Way had already merged with smaller galaxies, grown its disk, formed its spiral arms, and settled into its quiet, steady rotation. And then, in one of its spiral arms, in a modest cloud of gas and dust enriched by earlier generations of stars, a new star flickered on. That star was the Sun. And around it, from the leftover material of the cloud, the planets formed, including the Earth. That was 4.5 billion years ago. The galaxy was already more than 8 billion years old at the time. Life appeared on Earth relatively quickly, within the first billion years after the planet formed. For most of Earth's history, life was simple and single-celled, microscopic organisms living in the oceans, slowly, patiently transforming the atmosphere, filling it with oxygen, preparing the way for more complex forms. Multicellular life appeared only about 600 million years ago, in the Cambrian explosion, a sudden blossoming of diverse, complex body plans. The dinosaurs appeared about 230 million years ago and dominated the planet for more than 150 million years, a span of time almost unimaginably long compared to the brief tenure of humans. The dinosaurs went extinct about 66 million years ago when an asteroid struck the Earth, clearing the way for the rise of mammals. The first hominins, our distant ancestors, appeared only about 6 or 7 million years ago. The first members of our own species, Homo sapiens, appeared only about 300,000 years ago. Recorded human history, from the first cities to the present, spans about 6,000 years. That is a tiny, tiny sliver of the galaxy's age. If you compressed the entire history of the Milky Way into a single calendar year, with the galaxy forming on January 1st, the Earth would form in late August, the dinosaurs would appear in late December, and all of recorded human history would occupy the last few seconds before midnight on December 31st. There is a deep, quiet peace in those numbers. The galaxy is so old, and our time here is so brief, that the small worries and urgencies of daily life can seem, for a moment, to soften and dissolve. The galaxy does not care about your deadlines. It does not care about your embarrassments or your regrets or your unfinished tasks. It has been here for 13 billion years, and it will be here for billions more. You are a tiny, precious, fleeting part of it, a moment of consciousness in a vast, ancient structure. And that is not a cause for sadness, it is a cause for rest. You can let go of the need to control everything, to solve everything, to understand everything. The galaxy does not need you to solve it. It simply is, and you are part of it, and that is enough. The Milky Way's exact formation history is still actively studied and not fully settled. We know the broad outlines. The galaxy formed from the collapse of a large cloud of gas and dark matter in the early universe, and it grew over time by merging with smaller galaxies, drawing in gas from the surrounding intergalactic medium, and gradually building up its disk and bulge and halo. But the details of that history, how many mergers there were, when they happened, how massive the progenitor galaxies were, are still being worked out. Astronomers study the motions and chemical compositions of stars in the halo to reconstruct the galaxy's history. They have identified streams of stars that appear to be the remnants of smaller galaxies that were torn apart and absorbed by the Milky Way billions of years ago. One well-documented merger is with a galaxy sometimes called Gaia Enceladus, or the Gaia Sausage, which merged with the Milky Way about 10 billion years ago and contributed many stars to the inner halo. There are other streams and substructures, each one a clue to the galaxy's complex, layered past. But the full story is not yet known, and that not knowing is part of the calm. The galaxy is a puzzle that does not need to be completely solved tonight or ever. Looking forward, the future is just as slow and patient as the past. We have already talked about the eventual merger of the Milky Way and Andromeda, which is expected to begin in about 4 billion years and to complete over the following few billion years. That merger will transform our galaxy, turning it from a barred spiral into a large elliptical galaxy, a vast ball of old stars with little gas or ongoing star formation. The Sun, by that time, will be nearing the end of its life. In about 5 billion years, the Sun will exhaust the hydrogen in its core and begin its transformation into a red giant, swelling to many times its current size, engulfing the inner planets, and eventually shedding its outer layers to form a planetary nebula. The Earth, if it is not swallowed by the Sun, will be baked to a scorched, lifeless rock, its oceans boiled away, its atmosphere stripped off. All life on Earth will have ended long before then, simply due to the gradual brightening of the Sun over billions of years. The Sun is slowly getting brighter, about 10% more luminous every billion years. In about 1 billion years, the increased heat will make Earth uninhabitable for complex life. The oceans will begin to evaporate, and the planet will become a hothouse world. In about 5 billion years, the Sun will die, and the galaxy will go on, with new stars forming from the gas returned to the interstellar medium, new planets coalescing around them, new possibilities for life arising in the quiet, patient cycle of star birth and star death. Long after the Sun is gone, the galaxy will continue. The merged Milky Way Andromeda system will age gracefully, its star formation gradually declining as the gas is used up or blown out. The most massive stars will die quickly, leaving behind white dwarfs, neutron stars, and black holes. The lower mass stars, the red dwarfs, will keep burning for trillions of years, their slow, steady fusion unfazed by the passage of time. Eventually, after many trillions of years, even the red dwarfs will exhaust their fuel and fade to white dwarfs. The galaxy will become a dim, quiet place, populated by stellar remnants, cold planets, and dark matter. And then, on even longer timescales, the white dwarfs will cool to black dwarfs. The orbits of stars will decay due to gravitational radiation, and the galaxy will slowly evaporate, its stars scattered into intergalactic space or consumed by the supermassive black hole at the center. These are timescales of tens of trillions to quadrillions of years, numbers so large that they lose all meaning. The universe is still young compared to the time it will take for these processes to unfold. There is no urgency in any of this. None of it will happen in your lifetime, or in the lifetime of your children, or your grandchildren, or any generation of humans that will ever live. The sun will not burn out for 5 billion years. The Milky Way and Andromeda will not merge for 4 billion years. The galaxy will not fade for trillions of years. These timescales are so far beyond the human scale that they can feel like a release, a letting go, of the need to worry about the far future. The universe is not in a hurry. The galaxy is not in a hurry. The processes of deep time unfold with a patience that the human mind can only glimpse, and that glimpsing is enough. You are alive now, in this moment, in a galaxy that is in its prime, a galaxy full of star formation, full of young, bright stars, full of nebulae and clusters and planets and possibilities. You live in a time when the night sky is rich with stars, when the band of the Milky Way is visible to the naked eye, when telescopes can reveal the intricate beauty of spiral arms and star clusters and distant galaxies. This is a good time to be alive, a good time to be resting here, in the quiet, looking up at the sky or simply picturing it behind your closed eyes. The galaxy is old, but it is not finished. It is still forming stars, still creating new worlds, still drifting through space with its neighbors, still moving in its slow, patient orbit. And you are part of that, a tiny, conscious piece of a 13 billion-year-old structure, able to know it and love it and rest in it. The deep past and the slow future are two ends of a vast, quiet arc, an arc that stretches far beyond the boundaries of any single life. You sit at the midpoint of that arc, in the present moment, in the dark, listening to these words. Behind you is 13 billion years of cosmic history, the formation of the galaxy, the birth and death of countless stars, the enrichment of the interstellar medium, the formation of the sun and earth, the rise of life, the long, slow evolution that led to you. Ahead of you is billions of years more, the death of the sun, the merger of galaxies, the slow fading of the cosmos. And in the middle, here and now, you are resting, part of this great, quiet story, a story that does not need to be rushed, a story that does not need to be solved, a story that simply is. There is a peace in that perspective, a peace that comes from knowing your place in the cosmos. You are not the center of the universe. You are not the purpose of creation. You are a small, precious, temporary being, made of stardust, living on a small planet, orbiting an average star in a quiet arm of a barred spiral galaxy. And that is enough. That is more than enough. The galaxy is ancient and vast and beautiful, and you are part of it, resting now in its quiet embrace, cradled by the same gravity that has shaped it for 13 billion years. The night is long and the galaxy is patient, and you have all the time you need to drift a little deeper, carried by the slow, ancient rhythms of deep time. What remains unknown? The night is long, and the galaxy is patient, and you have all the time you need to drift a little deeper, carried by the slow, ancient rhythms of deep time. We have traveled together through the shape and the motion and the life of the Milky Way, through its stars and its gas and its quiet, turning arms. We have sat with what is known, the settled, verified facts that astronomers have pieced together over centuries of careful observation. But now, as we approach the end of our journey, we can sit for a while with what is not known, not as a problem to be solved, not as a frustration to be endured, but as a peaceful resting place, an open space where the mind can settle without needing to grasp or hold or understand. The exact total mass of the Milky Way, including all its unseen matter, is not precisely known. That is the first and perhaps the most profound uncertainty we can sit with. We know the mass of the stars, roughly, from the light they give off. We know the mass of the gas and dust, from radio and infrared observations. But when we add up all the visible matter, all the stars and gas and dust and planets and black holes, the total is not enough to explain the way the galaxy moves. The stars in the outer parts of the disk orbit too fast. The galaxy should fly apart, based on the gravity of the matter we can see. But it does not fly apart. It holds together, rotating steadily, its stars moving at speeds that imply a much greater mass than what is visible. This is where the idea of dark matter comes in, and it is an idea we can approach calmly and plainly, without any drama or mystery. Dark matter is simply matter that does not give off light. It does not emit, absorb, or reflect electromagnetic radiation of any kind. It is invisible to our telescopes, not because the telescopes are not good enough, but because dark matter does not interact with light at all. We know it is there, or at least, we are very confident that something is there, because we can measure its gravitational effects. The gravity of dark matter pulls on the stars and gas in the galaxy, shaping their orbits, determining the rotation speed of the disk. Without dark matter, the Milky Way would not look or behave the way it does. The same is true for other galaxies, and for clusters of galaxies, and for the large-scale structure of the universe. Dark matter is a fundamental part of the cosmos, a quiet, invisible scaffolding around which the visible matter has gathered. But scientists do not yet know exactly what dark matter is made of. That is the open question, stated simply and without frustration. There are ideas, of course. The leading hypothesis is that dark matter consists of some kind of subatomic particle that interacts only through gravity and the weak nuclear force, a particle that does not feel the electromagnetic force at all. Such particles are sometimes called WIMPs, which stands for weakly interacting massive particles, though the name is just a placeholder. Other ideas include axions, which are very light particles proposed for other reasons in particle physics, or even more exotic possibilities. But the honest truth is that we do not know. Despite decades of searching, despite sensitive detectors built deep underground to shield them from cosmic rays, despite experiments at particle accelerators and observations with space telescopes, no definitive signal of dark matter particles has been detected. The nature of dark matter remains one of the great open questions in science, and that not knowing is not a flaw, it is not a failure, it is simply the current state of our understanding, and it is a peaceful state to rest in. The universe does not need to be fully solved tonight. The galaxy does not need to reveal all its secrets. Dark matter is there, whatever it is, holding the Milky Way together, providing the gravitational glue that keeps the stars in their orbits. And you are resting inside that same gravitational field, cradled by the same dark matter halo that surrounds the galaxy. You do not need to know what it is made of to feel its effects, to be held by it, to trust that it is there. The galaxy is stable and real and beautiful, even if one of its major components remains mysterious. The precise total number of stars in the Milky Way is another open question, as we sat with earlier. The estimates range from about 100 billion to 400 billion, and that wide range reflects the real difficulty of counting stars from our position inside the disk. The exact number depends on how you define the edge of the galaxy, on how many faint, low-mass stars there are, compared to bright, high-mass ones, on the distribution of stars in the halo and the bulge and the disk. Different methods give different answers, and none of them is perfectly precise. The star count is an estimate, a best guess based on the available data, and it will probably be refined over time as new telescopes and new techniques come online. But for now, the not knowing is part of the calm. The galaxy contains a vast number of stars, more than you could ever count, more than you could ever visit or name or hold in your mind. The exact figure does not matter. What matters is the abundance, the richness, the quiet plenty of 100 billion suns, give or take a few 100 billion. The exact shape of the outer disk is another uncertainty, a gentle, soft-edged uncertainty that reflects the difficulty of mapping a galaxy from the inside. We know the Milky Way is a barred spiral. We know it has several major arms and several smaller spurs. But the precise number of arms, their exact paths, their extent, and their structure are still matters of active research. Different tracers, different types of stars or gas clouds, give slightly different maps. The spiral arms are not sharp, well-defined structures. They are regions of higher density, and their boundaries are fuzzy, their shapes changing over time as the galaxy rotates. The outer disk is even less well mapped, with its warp and its flare, It's bending and thickening at the edges. The galaxy does not have a clean, sharp edge. It fades out gradually, the stars becoming sparser, the gas thinner, until there is no clear point where the Milky Way ends and intergalactic space begins. That softness, that lack of a hard boundary, is not a problem to be solved. It is just the way the galaxy is, a diffuse, fading structure, a gathering of stars that gradually gives way to the void. The formation history of the Milky Way is also not fully settled, as we touched on in the last section. We know the broad outline. The galaxy formed early in the history of the universe, grew by merging with smaller galaxies, and gradually built up its disk and bulge and halo. But the details of that history, the number and timing and masses of the mergers, the origin of the thick disk and the thin disk, the history of star formation and chemical enrichment, are still being pieced together from the evidence. The stars in the halo carry the chemical fingerprints of their origins, and astronomers are slowly reading those fingerprints, reconstructing the family tree of the galaxy. But it is slow work, patient work, and it is not finished. The galaxy's past is not a closed book. It is an open question, a story that is still being written, a story that may never be fully complete. And that openness is something to rest in. The galaxy does not need to have a finished history. It is enough that it has a history, a long and complex and beautiful history, and that you are part of it. There are other open questions, smaller ones, quieter ones. The exact mechanism that triggers the collapse of a molecular cloud to form stars is not fully understood. We know the broad picture. Gravity pulls the cloud together. The center heats up. Fusion begins. But the details of how the cloud fragments, how the initial masses of stars are determined, how magnetic fields and turbulence affect the process, are still being worked out. The exact behavior of the supermassive black hole at the center, its feeding and feedback cycles, its influence on the surrounding bulge and disk, is still being studied. The nature of the Fermi bubbles, two enormous lobes of hot gas rising above and below the galactic center, detected in gamma rays and X-rays, is still debated. The galaxy is full of mysteries, large and small, known unknowns that keep astronomers curious and busy and patient. And that is a good place to rest, here at the edge of what is known. The universe does not need to be fully understood to be beautiful. The galaxy does not need to be fully mapped to be your home. You do not need to know the exact mass of dark matter, or the precise number of stars, or the complete history of the Milky Way's mergers, to lie here in the dark and feel the quiet presence of 100 billion suns around you. The not knowing is not a void to be filled. It is an open space, a breathing room, a place where the mind can rest without needing to grasp or hold or solve. The galaxy is vast and ancient and beautiful, and it contains mysteries that may never be fully answered. And that is fine. That is more than fine. That is part of the peace of the night, part of the quiet that surrounds you, part of the slow, patient rhythm of a universe that does not owe us all the answers. Scientists will keep working, of course. They will keep building telescopes and detectors and computer models. They will keep mapping the spiral arms, counting the stars, searching for dark matter, reconstructing the galaxy's history. Knowledge will grow, slowly, incrementally, over decades and centuries. Some questions will be answered, and new questions will arise in their place. That is the nature of science, a slow, patient, never-ending process of discovery. But you do not need to wait for those answers. You do not need to stay awake until the mysteries are solved. You can rest now, in the midst of the unknown, surrounded by the quiet presence of a galaxy that is only partly understood. The Milky Way is your home, whether you know everything about it or not. The stars are still there, whether you have counted them all or not. The dark matter is still holding everything together, whether you know what it is made of or not. And the night is still here, dark and quiet and calm, inviting you to let go of the need to know, to understand, to solve. Just rest, just breathe, just be, here, in the open, peaceful space of what is not yet known. Just rest, just breathe, just be, here, in the open, peaceful space of what is not yet known. The night has carried us a long way, through the shape of the galaxy and the place where we sit inside it, through the slow motion of the sun around the center and the quiet, dense heart of the black hole, through the lives of stars and the thin breath of gas between them, through the neighbors that drift alongside us and the deep, patient reaches of time. And now, at the end of our journey, we can simply be here, together, in the stillness, letting everything we have heard settle like soft dust in a quiet room. We began with an image, a simple image of lying on your back in the dark, looking up at the night sky, not as a distant dome, not as a faraway void, but as a ceiling, a close and gentle ceiling, the inside of your own home. That image has been with us all through the night, and we can return to it now, letting it carry us the last, soft distance into sleep. You are not looking at the Milky Way from the outside. You are inside it. You have been inside it this whole time, every moment of your life, every night you have ever slept, every day you have ever walked beneath the sun. The galaxy is not somewhere else. It is here. It is now. It is the room you are resting in, a room so large that its walls are made of stars, a room so old that its foundations were laid before the Earth was born. You have been inside the Milky Way this whole time, moving slowly through space without feeling it. The Earth spins on its axis, carrying you in a gentle circle once a day. The Earth orbits the Sun, tracing a path through space once a year. The Sun orbits the center of the galaxy, a vast, slow journey that takes 220 million years to complete. And the galaxy itself drifts through the local group, moving relative to Andromeda and the other nearby galaxies, part of the larger dance of the cosmos. All of this motion is happening right now, in this moment, as you lie still in the dark. You do not feel it. You have never felt it, but it is real, and it is steady, and it is carrying you through the universe, as gently as a river carries a leaf. Remember the slow orbit of the Sun, that 220 million year circuit around the galactic center. The last time the Sun was in this part of its orbit, the dinosaurs were just beginning to appear on Earth. The continents were joined together in a single landmass. The first mammals were small, scurrying creatures in the undergrowth, and the Sun sailed on, quiet and steady, carrying its planets through the spiral arms, through regions of denser gas and brighter stars, through the thin, cold spaces between the arms. It has made this journey only about 20 times since it was born, 20 galactic years. That is all. The galaxy is so large, and the orbit is so slow, that even the oldest things in our solar system are newcomers here, just beginning to explore the vast, turning wheel of the Milky Way. Remember the quiet nurseries of stars, the dense, cold clouds of gas and dust where new suns are being born. The Orion Nebula, glowing faintly in the winter sky, is one of those nurseries, a place where hundreds of new stars are forming right now, their light just beginning to shine, their planets just beginning to coalesce from the swirling disks of material around them. And there are other nebulae scattered through the spiral arms, places with names like Carina and Eagle and Lagoon, each one a cradle of creation, each one a quiet, ongoing miracle of gravity and fusion and light. The galaxy is not finished. It is still making stars. It has been making stars for 13 billion years, and it will keep making them for billions more. The breath of the galaxy, the thin interstellar medium, is still rich with the raw material of creation, still collapsing into new suns, still giving birth to new worlds. Remember the vast, patient timescales, the deep time that stretches far beyond any human urgency. The Milky Way is about 13 billion years old. The Sun and Earth are about 4.5 billion years old. Life has been on Earth for most of that time, slowly, patiently evolving from single cells to the rich diversity we see today. And ahead of us lies an even longer future. The Sun will shine for another 5 billion years before it begins to fade. The Milky Way and Andromeda will merge over billions of years, transforming our galaxy into something new. The stars that are being born now will live and die and return their material to the interstellar medium, and new stars will form from that material, and the cycle will continue, over and over, for trillions of years. None of this is urgent. None of this needs to be rushed. The universe has all the time it needs, and you, resting here in the dark, can let go of your own small urgencies, your deadlines, and your worries and your to-do lists, and simply float on the slow, patient river of cosmic time. You are made of the same material as the galaxy. The calcium in your bones, the iron in your blood, the oxygen in your breath, all of it was forged inside stars that lived and died billions of years ago, on the other side of the Milky Way. Those atoms drifted through the interstellar medium for eons, part of the quiet breath of the galaxy, before being gathered into the cloud that formed the sun and the earth. You are stardust, literally, not as a metaphor, but as a settled, verified fact. The galaxy is not just around you, it is inside you. Every atom of your body, except for the hydrogen, has been through the heart of a star. You are a piece of the Milky Way that has become conscious, that can look up at the night sky and wonder about its origins, that can lie in the dark and listen to a quiet voice describing the shape of its own home. You belong here. You have always belonged here. You will always belong here, even after your atoms return to the interstellar medium and are gathered up into new stars, new planets, new life. There is nothing you need to do with any of this. There is nothing you need to remember, nothing you need to hold on to, nothing you need to solve or understand or figure out. The facts we have shared tonight are real, and they are verified, and they are part of the quiet, settled knowledge of astronomy. But you do not need to keep them. You can let them drift away like leaves on a slow stream, like clouds across a dark sky. They have served their purpose, if they have helped you rest, if they have given your mind something calm and vast to settle on, if they have eased the transition from the busy day into the quiet night. The galaxy does not need you to remember how many stars it has, or how fast the sun is moving, or what dark matter is made of. The galaxy simply is, and you simply are, and that is enough. So now, as the night deepens and your body grows heavier against the mattress, let yourself drift. There is no more to say, no new facts to introduce, no final point to make, just the slow, soft echo of what has already been heard. The Milky Way is your home galaxy. You are inside it, resting in the Orion Arm, about 26,000 light-years from the center. The galaxy is a barred spiral, a great turning wheel of stars and gas and dust, held together by gravity and by the quiet, invisible presence of dark matter. The sun orbits the center, carrying you with it, moving at 230 kilometers per second through a journey that takes 220 million years to complete. The stars are being born and dying all around you, in nebulae and supernovae, in a cycle that has been repeating for 13 billion years. The galaxy has neighbors, the Magellanic Clouds and Andromeda and many smaller companions, all part of the local group, all drifting together through the vast, quiet night. And there are things we do not know, open questions that remain peaceful and unresolved, mysteries that do not need to be solved tonight. You can let go of the need to follow the words. You can let the voice become a soft, distant murmur, like rain on a roof, like wind in the trees, like the sound of the ocean from far away. You are not required to stay awake. You are not required to listen to the end. Sleep, when it comes, is the natural and welcome conclusion to this journey, the quiet drift into unconsciousness, the surrender to the deep, peaceful pull of your own tired body. The galaxy will still be there when you wake. The stars will still be shining. The sun will still be moving in its slow, patient orbit. The nebulae will still be forming new stars. The supernovae will still be scattering new elements. The black hole at the center will still be sitting quietly in its dark, dense heart. Nothing depends on you. Nothing needs your attention. You are free to let go. So let the image of the night sky, the soft ceiling of stars, be the last thing in your mind as you drift away. You are lying beneath the galaxy, or rather, inside it, wrapped in its immense, quiet presence. The stars are all around you, in every direction, above and below and to every side. They are moving in their own slow orbits, some of them with planets of their own, some of them with life that may be looking up at their own night sky, wondering about their own place in the cosmos. The universe is vast and full of light, and you are part of it, a small, precious, temporary piece of a beautiful ancient whole. The night is deep and calm. The words are fading now, trailing off into the quiet. There is nothing more to say, nothing more to hold, nothing more to do. Just the slow, steady presence of the Milky Way, turning in the darkness, and you, resting inside it, cradled by gravity, made of stardust, drifting gently, peacefully, into sleep. The galaxy has been here for 13 billion years, and it will be here for billions more. And you, in this moment, are part of it, a quiet breath in the long, slow life of the cosmos. Let that be enough. Let that be everything. Good night.